While it may be super quiet for you YouTubers, the Twitchers are listening to DJ Everyday, who is one of the PEX Philadelphia DJs. What up, Brink? It's okay that you're muted. Brain is not functioning today. Oh, is it staticky mic? Hold on, hold on. That should probably be cleaner. Let me know if there's still static. I have all kinds of ground loop issues with this setup. I really need to reinvent everything and, you know, start from scratch and treat it like a studio. It's been kind of a totem pole of technology as I get through streaming for a long time. So it's been a long time since I've torn everything out and started over again, which is kind of a thing that I need to do. It sounds like a dying cable. It's very possible that this cable has had its last. I need to order a couple more of these. Maybe I'll do that right now. If I squeeze this, does it get worse? How's that sound? Do I still sound okay? There's a couple spots in this cable where it's been squished by the chair, so that may be part of it. But it could also be my audio mixer. It could be me hitting something that's grounded. It still sounds staticky. Like listen back to. Oh, did we run out of mix? Come on. Wait. What happened over here? Oh, it's just a break in the song. All right, let me try that again. How's that? Everything's getting kind of old. Here, I'm going to go on Amazon. I'm going to buy 2 more of the cables, the mic cables. Clearly, I get my usage out of them. I can switch to my other cable too, and we'll see if that's it. Returns and orders. XLR or mini XLR. And then there's this one, audits. Wow, $30 for this cable? Are you kidding me? Well, I use them. I use them every day. It might be just peaking. That might be just what's going on. I don't know if it would necessarily be the cable. Although I'm well into the orange, I'm actually not peaking. Yeah, and maybe when we get some more people in here, somebody else can also back you up on that, make sure that it is me. Oh, you subbed for 20 months. Thank you, Brink. Sorry about the scratchiness. I need to start up AutoCAD. Oh, there's my address right on the screen. Let me close that. Now, I don't want to get bogged down in making parts. I think we can relatively quickly build the parts, but RF interference, I don't know where that would be coming from. If I turn this off, do you hear it? Is it still... It cuts out when I stop talking? It's not the fan in the background, is it? What if I get up and move? Move the fan over here. This is me being really close to the fan. I don't know. The noise gate, yeah, it's something in the microphone, man. Let me get the other cable out and let me do a little cable swap here. I'll do a quick little cable swap. How's that sound? Anything back? If you listen back to it, you'll hear it. Maybe I'll open up the file. I don't have headphones plugged into this computer, and we're gonna have to, I don't know, I'll have to do headphone testing at some point. But this is the new cable. This is the new cable, who dis. Perhaps you can't hear anything. And now new cable with this thing on. I don't know if that's causing, I don't think it would be causing any interference, but it's the same. So then it's not the, channel 2 needs to be a little hotter. Channel 3 needs to be a little quieter. Does it only let me go in one direction? Oh, I see. I'm changing the wrong one. Channel 1. There we go. So yeah, this is the mixer. If I swap these to the other channels, you can see what's being mixed together on the right and left channels. So that's square and sawtooth. And then this one is sine wave, square wave, or sine wave, sine wave, triangle wave, or whatever. It sounds like we tuned to Radio Free Bother 600 megahertz. What the fuck is going on? Hold on, let me listen to myself again. Like, where would that be coming from? I've plugged and replugged, and none of my settings are different. And again, it still happens. Does it still happen when I turn this thing off? If that thing is off, you guys still get the weird noise. I don't understand. Hold on. How about that? What do I sound like now? Is there still heavy static on the line? Is it still, like, fucked up? It's worse. How about now? Do I still have static in my voice? Does it sound awful? Yes. Now the compressor I think is still going. Yeah, that's over here. But it's like none of my speaker settings have changed. So I don't know what it could be. What does it sound like now? You guys gotta let me know. Do I sound like normal bother without static all over my voice? Because we changed cables, we changed drivers, and we changed microphones. What's up, Gonad? Apparently there's some sounds like bad connection. Fucking shit. Nothing changed. Wait, what wait, I see audio on the second line. What the? Whoa, look at this. Why is that happening? Check this out. So as I'm talking to you guys, I'm looking over here, and this channel keeps doing something. 1, 2, 3, 4, let's have a thummy war. See that? What if I just unplug the second channel? Assuming that I could do such a thing. Test 1, 2, 3. Cross talk on the. What the fuck? What happened? What the? Okay, hold on. Why are the two channels lighting up? This one should not be there. Okay, is that, why am I coming through on two channels? What in the fuck? Am I looping? It keeps getting worse. Amp has pooped the bed. Oh, for fuck's sake. What in the fuck? Hold on, okay, let's see. I don't know the Focusrite to die like that. That's a weird thing. I don't know if I have a backup for the Focusrite because that was kind of expensive. Let me do the classic, turn it off and turn it back on again. I don't think, yeah, speakers, Scarlett 2i2 USB. All right, so everything's gonna go crazy. Focusrite repair stream. How would I even be able to begin with that? Okay, hold on. This is gonna fuck everything up. It's just gonna, stuff's gonna get nuts. Oh, it's very dusty. 3, 2, 1, go. Go. Any more crosstalk going on? You little crosstalky bitch. What are you doing, huh? Nothing. Okay, I don't see crosstalk. That fixed it. Yeah, okay, so it was the Focusrite getting a little wiggy. I don't know why it did that. Maybe some kind of a memory thing. Fun. Okay, so I'm gonna swap all of my more aged gear back and put all of the gear that Julian normally wears back into the thing. So I'll be a minute here. So that was just the Focusrite going weird. Those have a limited life? Does it say on 24/7? Yeah, because it's a piece of solid state electronics. It doesn't need to be, you know, babied. Not like it has vacuum tubes. What's up, Hostile 1729? Yeah, that's weird. Focusrite, I guess, just gets a little weird. The audio setup on this computer is cursed. It's been through many iterations and many little temporary setups and stuff like that. So hold on, let me just swap all my gear. Almost exactly 7 years of uptime and they go bad? That's crazy. Bulb has an EEPROM that would cause the bulb to stop working after a certain amount of uses? I don't, you know, Focusrite is not exactly going to be doing that. That's a little conspiracy theory-y. All right, so Focusrite memory issues notwithstanding. It probably was just a memory overrun or something like that, because it seemed like it was getting crosstalk, which is inexplicable. Why didn't the device work again? Well, that's a shady device. That's not Focusrite. This is for soldering aid. I'll put that back over there. All right, so anyway, I got 4 channels working. Boom. Yummy. RL fade of 1 channel, which would be sawtooth square wave, and then the other channel, which is sine wave triangle wave. There we go, sine wave triangle wave. Keep up with me. You can mix them. They start to look cursed. Now, what I haven't tested is frequencies and what is distorting, etc. This is why we love MOTU. MOTU is the goat of the budget audio interfaces. Focusrite, the 2i2 has been perfectly fine. Been perfectly fine. It's just sometimes it gets a little weird. I mean, if you saw the audio setup here, you would also sometimes get a little weird. We got to start up AutoCAD. AutoCAD. It's really, for the name, given the name, it really isn't that all that automatic. I kind of have to do everything on it. You know, like it's not really automating as much as I would like it to. I guess we can just represent this thing as, or did I already make this part? Oh, we can represent it as amplifiers. I have that all in. I did some testing and I did some attenuating to get the signal down to headphone level right before it goes into the audio interface. And this audio interface is actually getting the result of an inverting op amp. So it is getting its full differentials. I don't know what the advantage to that is. I'm just doing it because I had extra op amps sitting around. Otherwise, we would have 2 unused op amps in this thing. It's really obnoxious. I have an entire quad op amp doing input buffering. Then I have a quad op amp on the output doing the little flippity doodah in order to get differentials out of this thing. And then I have another quad op amp that's doing the controls, because those apparently needed to be buffered as well. I know it still says start streaming. It's people are unaware that I am literally looking at exactly what I'm broadcasting, because I'm a professional, and professionals don't leave that kind of stuff up to chance. I don't understand how some streamers start OBS and then have it in the background, and they just play their little game and they've got OBS in the background. How do you do that? I would not be able to do that. I need to have an entire other monitor. Well, the only reason that you're hearing the unces that you're fan is that you are on Twitch. If you're on YouTube, it's quiet, because YouTube is a wasteland of music copyright. You can't expose people to new kinds of music because you get copyright struck. So I'm listening to music right now as part of the intro, but only Twitch can hear it, and people watching the VOD can't hear it either. What do you mean, how'd I know? I'm literally the person broadcast. I know everything. I know it all. I know all of it. Whoa. Whoa. Infinite broadcast. All right. Yeah, that scratching noise is crazy. It's just the failure mode of the Focusrite, I suppose. I should probably swap 2 of these cables, and then the channels will be even. Let me do that. Let me take this one here and swap it with this one here. And now we'll be attenu-mixing. I call it an attenu-mixer because it is attenuating down to headphone levels and doing a little bit of cleanup as well as it goes. But now, okay, so now I can do this. And we've got the 2 that are being mixed together, square wave sawtooth, in order to make buzz sawtooth. And whenever I touch the mix, that's when this thing Whoa, whoa. It's when I touch the adjustment, they get a little weird just because I'm using the cables to do it. And they're in phase, the inputs and outputs. So we've got square triangle wave, which just makes kind of a more boring sine wave. It's not, that one's not very exciting. Aussie rack, same thing but upside down. Yeah, and full of spiders. Full of like deadly spiders. I would have liked to have computer audio going into this thing and see what it does on the outset. What I need to do in order to do that test to get outside audio in to the eurorack is I need another, basically an amplifier in order to get it up to plus minus 10 volts. Called a rack off. It uses the C word. Oh my God. Yeah, I'll have to make like an input attenuator so I can take just like normal audio in. But I mean, it's been hard enough without ADHD meds to get the stuff done. So I've been struggling a little bit. We've made good progress though. I mean, look at this thing. This is the output on the headphones, and this is professional audio standards. So it's approximately 1.7 volts max. It's about 3 volts. I've got maybe a little less than that. So 3 volts peak to peak is sort of your consumer, your pro-grade audio signals. I don't know if going into headphones with pro audio levels is a good idea, but apparently that's what they do. The more, I guess the more volts you get, the more clarity you get in your signal. But like, I don't know what's it going to do to an 8-ohm driver. I haven't tested that out yet. I just have it on the scope. That's all I've got going on right now. And this should be high Z, so it's not like it's getting the appropriate amount of current running through it. Everything hasn't, exploded and blown up. I mean, there's a little bit of heat from the headphone driver you can see over there. It's cold. We've got that Canada air going on now in the northern part of our country, my country. My damn country. This is my country. No, but anyway, so in America, we've got sort of because of global, the fact that we're detonating our whole fucking planet, the trade winds are a little weird. And so now we've got this like snapping cold that's coming down from up north. And it is going to be aggressively chilly the next couple days. But I'm here. We're streaming today, streaming tomorrow. Oh, I was looking at AutoCAD, right? We need to update? How is there not an update? Whoa. Unlock more with extensions. I wonder what I could actually run. Automate complex geometry and enhance the performance and aesthetics of your product. Don't mind if I do. The problem is I have to learn how to use these things, and these things are awesome. There's like some really cool stuff you could do with AutoCAD that might be unlocked because I'm in the creators program and they want to show off how awesome their software is. I like AutoCAD, I really do, but I don't have time to learn some of these alternative features. I have to figure out how to do electronics with it and make it look smooth and quick and punchy and fun, not to appease AutoCAD just because that's my show. In order to make my show popular, it needs to be fun, punchy. We need to start, middle, end, and often in engineering you don't get that stuff. So it's tough. It's a balance that I got to do. And then on the side, like I really want to make a generatively designed RC car body. Like the body and the outer shell would be one piece. It would look like that sort of like ejaculate spider web. And it would be super leggera. It would be light as hell. And when I take it out and drive it, if I turn too hard, it'll explode. I would love that. That would be so awesome. Thank you for the update, Lawn Dog. It's okay. It's okay, man. Explode, huh? I think it would be awesome. It would be really funny to crash into something and have it just detonate into component parts, even though the component parts are fairly small. This would be Julian's absurd mixer, his absurd volume knob. The design requires 6112. What the hell is that part again? The SOD. We're gonna end up doing parts today, aren't we? That's annoying. Now that I know what the overall layout's gonna be, we're probably gonna need to import a bunch of parts. Unless I've already got them. I tried to have the right parts so that we could do the size planning. All right, let's get rid of stuff we don't need. And unfortunately, I'm not going to be able to have clipping indicators. These are taking the place of the... Yeah, we've got a lot of little clerical things to do today to make this work. I'm going to need all those 88 4062s. What up, Herr Yes, sir, yes, sir. It's time to get the design down on paper. Not that I don't already have it in MS Paint CAD. And then I need to answer some fundamental questions here before we go too far into the design. I know what's going to be required of the design, but I don't want it to be 2 PCBs. I want it to be 1 PCB. I might not get what I wish. I may not get that. That may not happen. I have a part number length problem. This is way too big. This would be my output jack, right? Do I have... I guess I'm just using P3, 2, and 1, even though this is a stereo jack. My RL channels. Because of the RL channels, we had to use the voltage-controlled mixer, which allows us to have that complex interaction without needing a dual potentiometer. A lot of designs use a dual pot, and you have your input coming into the dual pot, and the dual pot just does a voltage divider thing in order to turn it up and down. That's all you really need for a mixer, to be honest. But I didn't want to do dual pots. I wanted to have things that were controlled simultaneously from one singular control without it needing to be a big, expensive dual pot. So that's where these attenuator, sort of voltage-controlled attenuation comes from. Because our right and left of this channel and our right and left of this channel are going to... Yeah, anyway, all right. And unfortunately, with this mixer, this... where is that? The 2164. With the 2164, when you control 2 channels at once, it acts like a resistor. Like there's like each channel's control input like acts like a resistor. So when you control 2 at once, that's like having 2 parallel resistors suddenly in your circuit to ground, and it messes up your voltage levels if you don't have something attenuating it properly. And so I need more op amps on the input. How much were these things? The ADA? $15 worth of op amp. That's crazy. It's really annoying. You get bulk discounts, but still. I came across a video showing the application of a buck boost converter that was very compact. That's something that I would have thought about doing for this in order to simplify and not need more op amps. If I had a buck boost as the positive and negative voltage value, and then the potentiometers would just go between those two. But I couldn't really figure it out. Couldn't really figure it out. And I don't want to get too experimental. I mean, this is the first, like, actual real circuit that I'm building that's not fully lifted off of other people. So I wanted to keep it simple. So I need to have the attenuation there on the control inputs. Unfortunately. I don't think I have this part, so I think we're going to have to make this one. An op amp chip here on the desk. I think this one bit the bucket, bit the big weenie in the sky. I'm going to put it over there just in case. How much money? I don't know. I don't really know because a lot of the stuff that's here I already had, and then these I bought 10 of these, so that's $50, little man. And then what else? That thing I bought 10 of, and I think that was $7. So yeah, I'm out quite a bit of money on this thing so far. But you can't get by like Hajiwo, you know. Hajiwo wipes a lot of his expenses under the carpet for you. You know, don't look behind the curtain. Everything's totally fine here. It's just a 30-cent project because he's only counting the major players in the circuit. He's not counting like the jacks and the PCBs and this and that and the other thing. You can really nickel and dime yourself, especially when working on hobby projects. It's best not to keep a spreadsheet for things like this. I guess I could, but also part of the expenditure of buying so many amplifiers is stocking myself up with parts that I want to use. So I didn't want to sweat the small stuff too much when choosing the IC that's going to replace the TL074. I looked at what was like new and in stock and had similar specs, and I didn't look too far into it because I wanted to have more time building. I'm not a team of engineers, and I'm not really even that professional when it comes to electrical engineering. So I just kind of said, this one looks good, end of discussion, and went with it. But I've known the lead electrical engineer on, an audio project, because I've been involved in some professional audio. And basically all the engineers would recoil when he would go to the shitter with the DigiKey catalog. He'd have the printed DigiKey catalog that was this thick on Bible thin paper, and he would go take a shit, and we'd all be like, here we go. So and out would come a project. And do this all day. Burp, burp. Looking pretty good. What I really should be doing is sending audio through this, but we're not there yet. We're not there yet. I only just got this thing working. There were a lot of issues with weird connections, bad connections, and then some of the issues were caused by parts that were in my part catalog that I would solder in, like resistors that I'd put in that actually have different values from what's there. Oh, what's that doing there? Get that out of there. Get him out of there. Where are we? We are... No. We're here? No. We're here. Aha. Careful now. Got the red wire. Yeah, that cut the wire of a particular color is absolute bullshit for anybody that knows anything about anything. I personally know quite a bit about explosive devices. Actually, way more than I let on to. And let me tell you, unless you're buying a product from a company, you're not going to be finding purposefully coded wire colors in anything. And you can say that makes a certain amount of sense logically, but I know factually, I know for a fact that the dipshits building devices are not color coding their wires. How do you know that, Bother? Well, it's in my CV. We spider-botted this thing. This is a symmetrical audio output chip, so we flipped it and soldered it in symmetrically still. Some of the problems I had were still with the soldering on this thing. This thing gets hot, though. This thing gets very hot. So we put a single pin header on it as a makeshift heat sink, which is doing its job. I mean, it's stable temperature right now. It's just not cold. Do I have the thermometer over here? Yeah, there it is. We haven't used this in a little while. Although, to be fair, the lepton core, the thermal imager, should know what temperature this thing is. That's almost 50 degrees Celsius. It says here, 48 degrees C. 48 C in F. Woo, tough crowd today. I guess we're building people up, but it's getting to be start time in a minute here. Maybe because it says AutoCAD ad, nobody wants to. 120 degrees Fahrenheit. Yeah, 118.4. So we can start actually putting this thing down on paper. I made quite a bit of progress. And everything works the way that it should. And I was able to do attenuation without adding an op amp. So we're going to be using AutoCAD today. And aside from, well, actually, what we need to do before even getting this thing down on paper is gauge whether or not we're going to have space for everything that I want on this thing. That's going to be the tough part. It's this is without a proper heatsink. I mean, this is with just a pin header on there. The real thing, I'll want to make something like a plane that'll absorb more of the heat. And that way it'll just dissipate out. My only thing is, like, do I want professional level audio or do I want consumer level audio? Julian may not know. You know, he would say, yes, the professional audio, Eurorack is for professionals. But I don't know whether or not I want 3 volts out or, you know, only a couple volts, 1 volt. Start to crystallize. I guess so. Music all night long. This is when DJ Everyday plays the song that tells you that it's house music. How do you know it's house music? Just listen, they'll tell you. I don't know how well calibrated that thermometer is. It's probably not. It is just a little infrared thermometer. All right, if we get another one of that guy from the other day, I'm going to have to put in spam limiting stuff on Nightbot. So Nightbot will be a little bit more aggressive about repeat messages, which I don't like. I don't want that. It's just that person the other day came in and wanted 100% of my attention at all times, and I can't do that because I'm working on stuff. I need to work on stuff on this stream, and it requires me to do what I do. That was, I don't know if they were doing it intentionally or not, but when you ban somebody like that, they come back and they tell you that they were drunk. Rare Parrot? I guess I don't have that one. I don't know if modern ICs suffer from that, depending on what the IC is. I don't think like that would necessarily do what you're describing as crystallizing. I mean, heat wear and tear is more to do with the expansion of the elements. And so different materials in interface with each other don't expand at the same rate. Expand and contract at the same rate. And so if you go through that repeatedly over the course of a long time, that can really wear down your electronics. House music all night long. All this technology just to do this. But the thing is, in eurorack, you never know what the hell's going to happen with your input signals. And so I have protection on this. All right. Music. Describing itself as house music. I will fade it away. And away it goes. Pause. You can see here in the little scope window that I have my attenuating mixer functioning. We've got two input signals. In the case of what we're observing, we have a sine wave, bonk, and a sawtooth, not a sawtooth, a triangle wave, sine, triangle. Unfortunately, the mix of sine and triangle is not all that good looking. It looks a little weird. The other two channels are sawtooth square to make a square tooth signal. And so you can use those squares in order to attenuate yourself a double frequency sawtooth, because you're instantly adding a positive or negative element and attenuating it down gets it to be a double frequency signal. That's kind of a weird little result of putting one on the other. But yeah, there's our square wave, and then here's our sawtooth wave, and they're being mixed together. Yeah, so I got the headphone board is all together. Actually, we're looking at the output of the headphone amplifier. Now, the output of the headphone amplifier is currently at pro audio level, so it's plus minus 1.7 volts, I believe, for a 3-volt PP. So right now we've got a 3-volt PP running out of this thing. I think it might actually be a little hotter than that. I can tune that, though. I can tune that with some different resistors in the loop. What's happening right now is you are looking at my signal output generator running at full amplitude. It's running at full amplitude, which is plus minus 10 volts, because that's apparently what eurorack audio does. It's like super hot audio. Some even do plus minus 12, but we're not going to accept that. So plus minus 10 volts is coming out of my machine at approximately a C note. It's like 260 something hertz, coming out through these wires into an operational amplifier in unity gain. Actually, no, 3 to 1 or 1 to 3 configuration. It is attenuating the signal that comes in. So the signal comes in at 10 volts hot, comes in, gets attenuated by our buffer amplifiers. Those are the initial op amp that's going to take the brunt of any signal coming in. They're high Z, so they're not going to take up any current, and that, you know, that just makes sure that audio coming in is clean and protects our inner circuitry from outside influence. So we got that first stage. That then goes into something that turns voltage into current. That current is then mixed using a voltage-controlled amplifier. The thing is, we got 4 channels coming in, right? And we need to attenuate all 4 of those channels as separate things. Do we really need to do that, bother? That is actually a good question. Do we really need to do that? Yes, they do need to be separate on their way in, because we have normalization, which means that when we unplug one of the right or left side, it goes to both. Is that why we need 4 separate ones? Hold on a second. Should I be running 2 channels into just one line? No. I think we need to, but there are no separate, there's not 4 individual controls for them, so what's the purpose? And if I'm not doing 4 individual controls, then that would be 2 channels, and then the next 2 channels we could use for volume, and then it would be 1 chip. Let's pen that. Let's think about that. Hold on. Let's just think about that. Let me put that into MS Paint just in case. Do these. Need. X. well, I don't want lines crossing. Just one. Because, like, I could then have the left-hand side sort of normalization, not normalization, the left side adjustment control there. Yeah, apparently normalization's when you unplug one of the channels, it'll then route your signal to both. So that would just mean a little crossover between the switches of the jacks. Because it would be like you'd have your one jack. Oh, wait. Your one jack with the switch. And your other jack with the switch. When you plug something in, it would disconnect that switch. But in the meantime, you just have that switch is connected to the other output. So that when you unplug one of these, it'll just route audio to the other one. That's a very confusing diagram. We'll get over that in a minute. Okay, anyway, so I'm not totally sure I need two of these things. Because in terms of separation, I had two extras, so I decided to double these up. Whereas we could have RNL volume control on these, and then we can have the channel mixing happening through these two. Wait, does that, hold on a minute. I have two rights and lefts coming in, and I would need them to not, no, that doesn't make any sense. This has to be 4, because we're controlling completely separate entities that go in completely separate places. So if I attenuate them up and down, they can't mix together. They're not allowed to do that. I'm thinking. Does that make any sense? I think that has to, yeah, because it's two separate right and left. And they're just totally independent channels. Right, okay, so we couldn't have done this any other way. Two completely independent right and lefts. The thing about the right and left, what is it? The right and left mix out here is that I need 2 more, and the other transconductance amplifiers, the ones that only have 2, have the same package. They come in the same package. There's still these giant chips with 14 pins. They're not giant, they're SO sized, but they're still too big for our PCB. So I'm stuck with 2 of these things. And then we have the signal coming out of those things. So these, they say they don't invert, and I guess the chip itself doesn't invert, but when you turn that current back into voltage, it inverts. So what happens out here is we have our signal coming in, it gets inverted right here, so it's 180 degrees out of phase. Then it gets mixed, and it's still 180 degrees out of phase. It then goes through the current thing over here. Now it's back in phase. So this is output audio right there. We could just take output audio directly from here. I could just run that into a headphone. That would save me a whole lot of space. But the thing is, like, I don't really know all that much audio engineering. And so I would rather, my dog is barking right now while I'm talking to you guys, and it's very distracting. I don't know a ton about audio engineering. And so I wanted to use a headphone amplifier. So I found the TPA6120A2. This thing, if you give it some nice, clean power, this thing can take your audio in and turn it into professional headphone levels. And it does a little bit, it does a modicum of frequency stuff, just a little bit of the kind of funky stuff that you would want to have happen in a headphone system. And so you're running this in unity gain. If I take the op amps, the leftover 2 op amps, because remember, these things come in 4s. So if I have these outputs here, I actually have two more op amps. 2 op amps is not enough to run my controls, so I actually need another one that takes the control voltage and it amplifies it or whatever, and it puts it into these multiple outputs, because these act as resistors to ground, and when you double up these, you get 2 resistors to ground, and so suddenly you need all this current in order to maintain the voltage. They recommended the datasheet just to put it through an amplifier so that it holds the voltage at the proper level. And again, that's what I did, and it makes the controls buttery smooth, but it means we have another chip that we have to put onto this board. This board is 100 millimeters by 10 millimeters. I don't have any space. And I've only got one side to put my surface mount ICs. Oh my God, it's so stressful. So anyway, that means that we've got 1, 2, 3 quad op amps going on this thing, and a headphone driver, and 2 of these SO14 parts. So the punchiest and the most fun thing that we can do today is put down components that will represent those sizes and see if we can really kind of wrench them onto that board. And at that point, I can make ICs in AutoCAD in order to actually put down the schematic. But so anyway, I use those extra 2 in Unity Gain, and I just basically invert the signal so that we can have a differential going into the headphone amplifier. We don't necessarily need to do that. It's just I've got the amps, so I might as well do something with them. And so that's what we're reviewing on the screen, is the stereo mixing of 4 channels. So here's 2 of the channels represented in just the monitor as a sawtooth and a square, and then we have our squawtooth right here, which is kind of like it's still like a metal saw. So we've got the mix of those 2, and then these are the other 2 channels. And so if I tune the controls here, we can turn one up and down or the other up and down. And then we have over here an overall volume control of everything. So you set up your mix, and then you set up your output in terms of attenuation. And this output can get hot. I mean, this goes above the levels. I tried to make it go above, like just a little bit above where the signals would normally be clipping, just in case you put in a signal that's soft and you want to actually boost it. I don't know if that's good practice or not. I think I probably needed to do more equations to get that all together, but I think it'll be good. I want to get something that has multiple audio channels that I could put into the breadboard setup and like just listen to the output. And I do want to hook this thing up to the speakers that are right here. I don't know if I'm gonna like fucking blow them up because I'm putting 3 volts into the speakers. I don't know. I did professional audio standards. I could attenuate it more in order to make it just consumer audio. So yeah, that's what we got. I guess I could probably adjust the gain at RF here, huh? Maybe that's where it needs to be adjusted. Instead of a 1K, I could put like a larger, smaller resistor there, and then it would take this 3-volt signal and attenuate it to either, which is where maybe I could do like a jumper on the main PCB circuit. I could do a jumper, and then you could set whether it's professional audio or consumer audio level, or maybe I could just swap out a resistor, you know, in the final product. That's the kind of thing. You see, we haven't done testing and we haven't done final schematic yet, but we're gonna put down the design and try to get that onto a PCB. Once I have it on a PCB, I can build it, then run some test signals through it. You see, this whole thing, the whole advent of $5 circuit boards is really spoiling the design process here. Hey, what's up, Groovy Something? How you doing? Man, Twitch users have such weird names. But yeah, so because of $5 circuit boards, we can just get the design down and just order it. And I'll put it together and I go, this is shit. And then I can put all kinds of like capacitors and stuff in there and refinalize the design. That's only like $100 to do 2 designs like that. So chillin', how you doing with this cold snap that we're gonna get? Are you guys getting it first? I don't know. I really need to try and make a circuit board. Prices are great. See, I'm from the old school EE, I don't know, fucking fossils, where a circuit board design was like a commitment. And you would go to the board house and they would revise your design. They would go over it. They would make sure it's all correct. And then they would do the run, and it would cost you a lot of money, and you get this really shitty circuit board with no solder mask on it, and you would have to go through your design and make sure that everything is perfect for the next iteration. It always took 1 or 2 iterations, but it was always really expensive. 48 here right now and warm in the sun. Yeah, I could probably go outside without a jacket on, but I would be a little bit chilly. I was out there in socks earlier, and it turns out the road surface was wet, so I had wet socks, the worst, especially when it's cold. But I guess it's going to snap cold tonight. It's going to get crazy. It's going to get crazy cold. I hope we get snow. What up, Ryan Labs? How you doing? Yeah, but look at this. I got the full attenu-mixer working with the headphone amplifier. I don't know. So a lot of my justifications on this project are a little bit shaky. Like, I could probably go into headphones directly out of my amplifiers. That may be something that I could just do. But I wanted to have a specific headphone driver, like a high definition headphone driver, in order to run these things. Like if we look at the TPA 6120, I'm getting very distracted. But like this thing, in applications requiring a high power output, very high fidelity headphone amplifier, replaces a costly discrete design and allows music, not the amplifier, to be heard. It's got a current feedback AB amplifier architecture, delivers high bandwidth, extremely low noise, and up to 128 dB of dynamic range. So 3 key features. High slew rate prevents odd order distortion anomalies. The second feature is current on demand at the output that enables the amplifier to respond quickly and linearly when large amounts of output power are suddenly needed. The amplifier can respond extremely quickly without raising the noise floor of the system and degrading the signal-to-noise ratio. Third feature is the gain-independent frequency response that allows the full bandwidth of the amplifier to be used over a wide range of gain settings. So, I mean, I don't know if those necessarily are needed. I do know that it at least gives us this diagram. I hope we get a lot of snow. I want enough snow that I can get a video of Willow jumping in and out of the snow. I wanted to get a puppy video of her doing that, but we haven't in the lifespan of my dog, we have not had a deep snow. So I was hoping we would get one. But yeah, so this is, I mean, this is their audio DAC design, but what I'm hoping to do, I hope I'm justified in using this headphone amplifier. I think maybe I could have gone with just the output stage of my amps, but anyway, we got to make sure that we've got room for this thing. And so what board house was I going to use again? I forget what the board house was. We need to make sure that all of our stuff fits. So for now that we know, and I've just finished going over, we know our whole design. We know that we need 3 quad operational amplifier chips. The V2164 only comes in SO14. And I should do a little bit of research right now. Let's just go to DigiKey and look up transconductance amplifier. So instrumentation, op amp, and buffer amps, special purpose amplifiers, it's 3 in there. And op amp evaluation boards. Let's just try special purpose. Transconductance. But, yeah, none of them are 8 pins. What the heck? None of them are like QFN packages. Transconductance. What packages do we have here? I'm interested in making this thing smaller. Active. 16. Oh, that hurts me. These are the only ones they have. And they're all SO sized. None of them are, oh God. That's a can. That's outright. Yeah, so we can't get smaller than SO. So we got to make SO work. Now, as an example, you guys have seen me kind of buzz by the page. I opened up 2HP's image of all of their modules, and I would like to be building more of these just tiny little eurorack modules. I'm gonna burp. 2HP loves to put PCB at a right angle in order to fit all the stuff in their panels. But we've also seen panels where they've squished all of the electronics onto the back side of this PCB here, the one that's holding all of this stuff, all the buttons and stuff. So that's pretty much what our scheme is going to be. Our power is going to come in on the 5-pin connector. We're going to have to cut the leads on the other side to make it flat. It's going to have to solder in, cut the leads really flat, and then all of the other stuff can go in. We have very, very little space in this circuit. So we need to kind of we need to make sure we get it right. Now, to get an idea of that size, and I can't believe we can't find the SO. This part does not come in any smaller sizes. It's very vexing to me. We can actually save time with integrated fastener library. Well, that's kind of neat. Yeah, so we can go from the PCB, and actually, wait, I need to update the design across so that it populates the components. So we have our 3 thingy-majigs. I need 2 placeholders for the SO14 parts. So SO14, we're going to go to the parts library here. we need placeholders in order to sort of position things. So I'm just going to find a, what can I find? Let's go to chips. Mega 328, no. ADA, those are those psychotically small amplifiers for the RC car. What do we got here? I know I've got something. See, I don't necessarily want to put down a, I could just put down an amplifier, but I would rather it be like one part that I could then identify and replace in the circuit. Ah, it looks like we're going to have to. Wait, what's this one? The WS2801 is, I think that's enough pins. So I'm just going to put 2 of these down. And those will be placeholders for our transconductance amplifiers. So, okay, so we've got a couple components in here. These are locked in. These potentiometers and the input jacks, they're locked in because I have them in very specific positions. They represent our front panel. So what we can do is we can actually go to the 3-dimensional PCB. We can generate the 3D PCB, and we can see this thing in real life. Well, in real CAD life. Oh yeah, we got to switch to the PCB. Now I've got a couple new components here. I will flip these to the other layer and just put them aside because, oh, well, actually these fit in. These must have smaller pads. Oh, that's interesting. That's going to help us out a lot, actually. Oh, and we can even fit it with, well, with a pin in the middle is going to be a little bit of a problem. It needs to pretty much go like that. But yeah, now we can actually see what this looks like IRL. So let's switch to the 3D design. We're going to generate it. These, I think, are the default settings, which I pretty much just leave. There are some settings here when you push when you push it to the 3D thing, you can go into the manufacturing tab, or is it? It's like a manufacturing preview tab, I think, and change some of the settings so that your layers look correct. If you're having a little bit of trouble with it, like if you really want to see the solder mask and stuff like represented properly, you could make it into a texture on there. But we're just going to generate everything in 3 dimensions because we haven't had too many problems lately with it. I've had to do all kinds of like weird tricks when working with this stuff. The background you see here is River Rubicon. It allows me to not blast everybody's eyes into space every time we use this software. And one of the settings that I think is coming down the pipeline is night mode, but I haven't seen anything about it. In the dev branch, there apparently is night mode. I don't know when that, I don't know how long that takes to trickle down to us mortals, but it'd be pretty cool. I mean, I have access to the dev branch. I just don't want to, I don't want to use it. I want what's stable. One thing that I do have to figure out is how to put little notches into the side of the circuit board. So these are what? 1, 2, 3, 4, 5, 6, 7. I think those are, well, SO14, is that what these are? Where is it? Where's the chip? Where's the chip? There it is. Oh, there's 2 more pins. Maybe that's why the other ones won't fit. So they're going to be a little bit longer than what we have here as a placeholder. Although they're not going to be that much different. Man, when did I generate this chip? It looks terrible. It looks like really bad. It looks really bad. Look at it. It's like the, what is it? It looks like the medieval cow paintings. Okay, all right. Willow looks like this too sometimes, where they're like square. That's what the chip looks like in this setup. There's no such thing as being out of space in something as large as a eurorack chassis. There is when you're a 2 HP module. Look at so little space, but it is looking on the up and up. It looks like we actually might be able to fit everything that we need to, because this is the 3 quad op amps and 2 SO, almost SO, you know, SO16s. We're gonna have to make a part, I guess. I wanted to avoid making a part, but we're gonna have to make a part. And then I'm gonna need one more IC that's about the same size. That one will have the heat sinks around it for the output. But this is looking like we might just make it. That's just what EU cows look like. Man, you guys are just out here huffing the metric system. You're going to get addicted to that metric unit system. It's a sad thing. I've seen it a couple times. So putting notches in the side of the circuit board is something that I need to figure out in terms of like routing and building. That's a bit of reading that I have to do. I would like to have those notches though. And then room for the tabs to come inside a little bit would be nice, but it might not be afforded throughout the rest of the design. I'm not sure. So let's, I wanted to avoid this, but we're gonna have to, things are looking like just hopeful enough that we would be able to fit everything in here, which is really unfortunate for me because that means that I now have to struggle to get all the other components, all the support components into this ludicrously small design. Damn it. I was hoping that would be a little bit more hopeless, but it seems like things are gonna be okay. Well, that's what 2HP does. That's what 2HP does. See that? That's what they do right there. Right there. See that? 2HP does the board on an angle thing. I don't really like this. I know it's acceptable to do things this way, but what that means is that you've got these right angle connectors coming up to the front board, and those right angle connectors on one of the ends, it's going to be a surface mount connection. And if you have a surface mount connection, a square pad on a PCB, that is notoriously weak, and it's where a lot of this stuff fails. What I would do personally, well, what I've seen done is people glue headers together in order to do that, and I don't like that either. What I would do in this scenario is solder through hole on both ends and then clip the pins so that they're flush. Maybe even file them down a little bit, or better yet, clip the pins so that they are a little bit inset in the via, and then solder that so that you have solder going up and out to the outside of the via. What that's going to do with that via there, that via is going to act like a rivet, and that rivet's going to hold things really, really strongly. It's basically going to be two slices of metal on either side of your FR4 fiberglass, instead of the adhesive strength of a flat pad onto the FR4, which will just peel off. Board to board, angle to board. I've seen board to board soldering before too, where you have a pad on each side of the board and you solder above and below. That holds okay, but again, it's going to a flat pad. If you're good, you could put vias on that flat pad, and then those would act as rivets as well. That would be another way to do it. Yeah, the little like Raspberry Pi compute style standoffs, those sort of board-to-board interfaces, those are good too. I've also seen just pin headers. You just use pin headers to hold everything on. I could do that easily. You don't need to get that complicated. You just do the low-profile round pin headers, and you don't even need to glue them, right? You just do the things that I use, whatever, whatever, you get what I mean. If you use pin headers like that, they lock in really tightly, and you don't run into any issue with that. I like these, yeah, these over here. And you just allow it to be a board-to-board interface, because like this is tough to peel off anyway as it is. These two channels here are cursed. Yeah, see there's the channel. I don't know why that's like that. I don't know what to do about that. My 6-channel wave output is actually 4 channels because I can't get the other 2 channels to work. Anyway. Well, yeah, I mean, the other thing is you sell it as a kit. And so if they want to plug it in any which way, that's on them. You give as many indicators as you can possibly afford to keep them from doing that. Or you just glue the headers, which I don't personally like. I'm a little worried about that too. Like when I get this design done and printed and ordered and everything's happy, how is it going to break? How am I going to lose my career to people suing me? Stuff like that. Keeps you up at night. Okay, so we've got to go for the ICs. And apart from the ICs, there's just a bunch of resistors and capacitors that go onto this thing. I don't know about sprinkling it with capacitors at the end of the design. We will figure that out when we get our first prototype made. For now, I need parts in here that are what I'm using, and then we need to put in the settings, the maximums, the mins and maxes from the board house that we're going to get this from. Well, those and warranty stickers are, I think, illegal now. You can't put a sticker on there and say warranty void if broken. Okay, so a lot of work still to do. We've done a lot of work. Let's get back into the schematic. And I guess, well, okay. Into the 2D design, I guess we can put the proper rules in here. I don't know. Which one do I want to do? I guess before the rules, let's get final parts in. So I'm going to delete these. And we are going to make some new components. We need the headphone amplifier, and we need the transconductance amplifier. Let's just check to see if I haven't done the transconductance amplifier before. What's part number on that thing again? I hate to go into parts manufacturing because that's kind of where we spend most of our time, but that's what I need to do right now. Excuse me, I'm burping. V2164. V300, but that's a big regulator. That's a huge voltage regulator. Okay, so we're going to make a new component. So we need to open up this library in the library manager. You'll see that I use the button right over there. So you click on the button, opens it up. One more cup of coffee, then back to fixing corroded vias. Hey, you know, that's more fun than this. No, you can't, like, legally, you can't say you broke the warranty sticker because that's illegal now. They made it illegal. So I only want in use, and these are my personal libraries where I keep the components. If you're using a program like, you know, AutoCAD, Eagle, I forget what they call it. What do they call it now? Autodesk Fusion, I guess, is just the whole product. But Eagle is what this originally was. So my parts libraries come from Eagle. You keep your own little parts libraries. You can pull things in from outside and, you know, leave the proper comments and stuff. But it's like, if I don't know how to share these libraries with the 3D components. I hope they figure that out soon, because I would like to host these on GitHub so that you guys can use, you know, my components and maybe even just fork your own branch and, you know, do some improvements on it and get me all the 3D models. I've been through these a couple times with a fine-tooth comb. I need to sit down with a whole pot of coffee and do it again. All of these components are very, very, very important to me because I know that they work. I've used them in designs. We are adding a new one in, and we're going to use it in design, and we're going to figure out what's going on with the component, whether or not we need to improve or you know, do stuff like that. It's a little bit of a mess, though. This has become a mess over the years. So, you know, I need to go through these, maybe even just make new libraries and move parts over from one to the other. Been legal to break that sticker since the 70s? Really? I thought there was a recent legislation that made it legal. But anyway, we're looking at chips managed. So we're going to edit the library. Boy, edit and remove right next to each other, huh? That's going to open up our library manager tab. And we're opened into the library in the component view. So when we click on something, it'll give us, when we double click on something, we open up a component, it'll give us the symbol. So the component is like the top of the tree, right? The component contains the different packages. It contains the 3D models, or the packages contain the 3D models. But the packages, the schematic diagram, you have a schematic diagram and the various components of it. Then you have a package associated with that, and that package has a 3D model associated with that. It's sort of, you go down the levels of the tree to make sure everything's good. What's illegal is saying you broke the warranty sticker and thus your warranty is void, provided nothing else is done that breaks the device. If you can guarantee that it breaks when opened and someone opened it, you're not liable for that damage. What? That's confusing. So nothing else to break the device. Guarantee that it breaks when opened and someone opened it. not liable for that damage. Well, that's tough to do. How would you? You'd have to intentionally make your device so that it breaks when you open it up. That'd be like a cell phone where everything's taped together. So we are coming up with a new component here, and I guess we are gonna use another package. I mean, we'll use an SO16 package on here, but our component, is it gonna have a unique symbol? I guess it will, unless we take it from the mutable instrument library. I could open up a mutable instrument design, and I could take that component from mutables and put it into ours if we have the full design file, which I do for some of them. Yeah, you can import. I haven't played with importing at all, but I would be shocked if you weren't able to import like KiCad and stuff. That's like some terrible IED style engineering, or if you open it up, it triggers something that you can't untrigger. Okay, so we're just going to do a totally new component. I'm just going to draw this one from scratch. So what I'm going to do is new component, and this is going to be a V2164. So here I need a new symbol. So I'm going to go up here and click on the new symbol thing, and this one's going to be V2164. And I need 2 input pins because it's basically, it's going to look like this. I'm essentially just going to draw this. It's pretty easy to do. We need 3 pins on this. And so it's going to be 3 pins, but there's going to be 4 of these things. So we take a pin, place it. Oh no, that's the rip up pin. Place a pin. Let's see, rotation to the left. Function is going to be, we're not going to worry about function right now. It's just going to be IO. Length is going to be short. And then display, I don't know. Let's just put that down there. What are the different ones? Both names, pin name, pad name, or visibility off. I think we want both. So we're coming from over here. That's 1. Actually, you know what? Just pin name, I think. 1, 2, 3. We'll just put them up for now. This is on the symbols layer. I think those automatically went to the pins layer. Short, none, visible, both. That's not telling me the layer. Okay, well, anyway. I got to get back into the swing of this. So I'm going to put that symbol there just so that it lines up with everything. And then we'll have all of our stuff over here. The pin name is a little distracting, actually. I probably want to just display the pin number. So visible pad. Cable boxes and tamper switches? Huh. Yeah, I guess we all could have gotten Skinamax if we had just popped our devices open and put like a diode in there way back in the day. Oh, that's a... Okay, so in order to do that, I just need 2 lines. That. Oh, wait, we're on the symbol layer? We want the symbol layer, right? Yeah. Buses, nets, modules, etc. Okay, so symbol layer, I'm just going to make a box. Oh, I need a line tool. I'm forgetting a lot of the stuff about making these. It'll come back to me eventually. I do like that Fusion is working in the AutoCAD alignment stuff. You can see how there's like right angles and centers popping up here, just like they have in their drawing interface. Because the sketch interface is really, really good. It's like lined up with center and maybe like that. See that? That just kind of helps you draw everything. Oh, but our symbol came into the... Yeah, it needs to be just 1 longer so that I have a center there. And that way the pin can line up. like that. That's a little big, isn't it? Well, how big are the ones for mutables? We could make it smaller. Like that's the symbol essentially, but I think it needs to be much smaller. I like my MS Paint CAD, to be honest. That's just going to move it. I need to actually... Bleh. Yeah, it's not going to let me make it smaller. All right, let's just make it smaller. And I'm essentially doing this by feel, so... There, much smaller. Doot, doot. Oops, that didn't quite work. No. There we go. Okay, so I guess, wait, this goes into the middle, doesn't it? Let's just double check. Yeah, it goes into the middle. What's up, Kellogg? Commander Kellogg's? No scale feature? There probably is. It's just, it was quicker for me to redraw it. I'm trying to move quickly here because we don't want to spend all of our time in parts generation. Yeah, so that's essentially going to be the symbol. It's just we need to now make it do multiples. I may need to do like a crash course. I keep forgetting how this stuff works. So I guess here we can put in text, and I can do name. I think it's actually done like this. It's going to detect this text and then actually replace it with the IC name. So on the name layer, and I'll just put that up here, and then value on the value layer. Oh, I guess name and names. Huh. There, name and value. My symbol might still be a little bit large, isn't it? I don't know. Take a look here. How big is this? I think that's okay. So I need, let's see, let's take a look at this one. Wait, no, I want to edit this one. Edit part. Edit the symbol. So it's name and value, and then when I get to the component put together, then it gets swap levels. Well, that one just says A and B on it. Wait a minute. 6004. What about the TLS-72? Oh, it just gets A and B. What about the, where's the one that I built? Oh yeah, so it just gets ABC, but then it's saying IC1D. This is the 8840 whatever. A and B. Okay, all right, all right. So, all right. Wait, which one is that? Oh, that's the tiny package. Yeah, the I put all the packages in there, but there's also a this the 4.1 is the one on the QFP. There we go. That's the one we're actually going to use. So it is just A, B, C, and D. All right. What am I edit part editing? Oh, we're in it. We're in it. Okay, so let's go back to the one that we were building, which is the V2164. And actually, we need to go to symbols because we didn't finish it yet. So V2164, name and value on that. Those are even. This one's even. It's a little awkward. It could probably be a little bit smaller, but I'm okay with it like this. Hey, wonky robot. Oh, sorry, I'm in the wrong. I must have clicked something terrible. Split miter lock dimensions. Nah, it doesn't look like I can take it and scale it down. Alt. Yeah, that's just going to move it on the grid. All right, so that's that part. Hit save. User saved. Now I need to go back into this, and I think I have everything I need now because it's just an SOIC, so this should be pretty easy to do. Now that we have our symbol. So the V2164 part, where is that? We need to add our symbol. So we'll put that first one right there. And now I need to add the other ones. So boom, boom, and boom. And then properties, name. So this one's C. And actually, editing the name in here isn't going to edit anything but what displays in here. So A, B, C, and D. A, B, C, and D, and then I need to add the power symbol. That's just these two right here. Is there a ground too? Actually, there's a bunch of pins that we need. So I think what I'm going to need to do is actually make a second symbol that's going to be the support stuff. D is misaligned a bit. I can tell you how little control I have over that. Oh, I see what you mean. That. There we go. That's not a big deal. This is just displaying it. So I need to make sure that I get it right. So let me just hit save quickly. And I need to open up one of these, something like a TLO74. Yeah, swap level needs to be 1 so that they're placed down. And then at swap 0, we can have the power thing. But what I need is all of the support stuff. So actually, I need a new symbol. New symbol and V2164 other stuff. And so what I'll do is I'll just make a little box that has these extra pins on them. What did mutables do for this? Curious about this. Power. Here's all of the invoked power pins from the other ICs. Looking for anything that can kind of tell us what the statuses of the other pins are. Huh. Oh, this is it. So V plus mode and ground. That's the V2164. So I am going to just do my own thing. I'm going to place a box. It's a little big, but let's get some pins on it. And let's see what the schematic, the actual data sheet makes it look like. Mode V plus ground V minus. Yeah, maybe I should do it horizontally. Not reinvent the wheel here. Actually, I'll put the pin 1, I'm going to put a 0. We'll do it out the right side. Let's go over here. Two, 3, 4. So P1 is going to be P plus, P2, mode, P3 is going to be, no, it's going to be ground, and then P4 is V minus. And then really, I'd only need the pin. Well, no, I'll have both. Where do I assign what pin it is? Okay, and then name. I don't know if this really needs a value, but I guess I'll give it that. Values. Just put that in there. A new board landed on my bench yesterday that I get to play with. Nice. Very nice. All right, so there's our V2164 stuff. This is the additional stuff that's required with the chip. And then we go back to this guy. No, wait, cancel. Let's click the wrong thing. There's the symbol. Go back in and open this, and then add the V2164 stuff. All right, so swap level needs to be swap level 1. Or no, well, this one can be 0. These are swap level 1. Properties, swap level 1. I guess that just means we invoke it. Okay. 2 times the 4-channel solenoid driver we did before, or 8 fuel injectors. Neat. Is that for like a mega squirt setup? I had the director of the technical building of the FBI sit next to us at lunch, and I was talking car with him. And at the time, I was working on a mega squirt system. And so all of my coworkers, or at least my coworkers who we ate lunch with, were like, "Did you just talk to the director about mega squirting for like 10 minutes?" And I'm like, "Yeah." What? What's wrong with mega squirting? They were a bunch of goons. I think that's going to give us our whole symbol. I think the CAD program takes the rest. It sort of knows that this is like one set, this is the other set. Problem is, I didn't assign any pin numbers for these things. I'm not sure if that. I should probably be able to assign pin numbers, right? Who's that? I can't see that. Joda Yolo. Joda Yolo. Joda Yolo. I don't know how to say anything. Hey, thank you for subbing for 18 months. I appreciate that. Did I miss anything else? I don't think I did. I don't, the YouTube, I'm not sure. We got Brink GG at the beginning of the stream. And does my Streamlabs, it doesn't monitor YouTube. So I don't know. I don't think anybody's done anything in YouTube. Yeah, it doesn't look like there's anything going on in there. I just don't know how I can tell. I don't have Nightbot set up properly for YouTube. YouTube is basically just where I'm dumping the VODs so that they're permanently up. That reminds me, I have injectors to install. I still have to fix my windshield wipers and get classic car registration. These are things that I would do if I had my meds, because I just don't think to do these things. I'll think about it on stream, but like, yeah, it's going to take, oh man, it'll take an effort for me to get some stuff done. Anyway, yeah, thank you for the sub, Jojo Yellow. So yeah, anyway, we're getting on. Like we're getting closer to making a part. Mine work, but they have rusty bits. My entire right side wiper, the non-driver, the passenger side. What is the non-driver again? The passenger side wiper doesn't work. The last time we got snow, which was 2 years ago, maybe a year ago, I've been going for a year without having two functioning windshield wipers. The one is great, except when it parks in view. It parks in, am I legally allowed to make that symbol? It's a windshield wiper, get over yourselves. But when the windshield wiper stops, it's like right in my view. I've got like this karate chop going on for the entire time that I'm driving. And the other side just fell because it's just like a pin. And so it snowed and iced, and so my wipers were iced, and I tried to move them manually so that I could scrape my windshield, and it broke. I didn't put something in tight enough, or maybe I forgot a pin or something, but I can get in there. There's just a whole bunch of like rain trays that I have to get out of the way in order for me to get in there and actually repair the wipers. And then I can clean out all the debris to make sure that my car is properly draining water, because that's what kills these cars, and it's currently eating away at mine, is that BMW, in their infinite wisdom, decided, yeah, instead of having a disgusting piss tube under our cars, we're going to have the disgusting piss tube internally go down and into a body panel that should then drain, maybe. But when it doesn't, it holds water and it ends up rusting. Obnoxious. This is two wipers that have a big complex path that they take. The one wiper that fell is one of those ones with two like arms on it. And so I need to, there's a whole system. It's like a bunch of levers under there that I need to make sure are pinned in place. The one fell and just doesn't do anything. The other one wipes perfectly, but then what I need to do is I need to turn it on the slowest setting, and when it goes away, turn my car off, turn my car back on. Well, turn my car off, turn the windshield wiper off, turn my car back on, pop the clutch out to start the car, and then it stays parked. That's how I have to do it. And I'm like, nothing to see here, officer. That body panel should have a hole. Is it clogged? Oh, no, no. No, 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 no. No, 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 no. It's not clogged. It doesn't exist. It's rusted away. The jack pads also happen to go into that panel too. And so as you jack your car up and down, it rubs the underbody coating, which is a rubbery coating that crushes, and it crushes and rubs that rubbery coating. And then the rubber is no longer on the metal. The metal gets wet because it drains from there in that area, and everything gets wet under the car. And so that rusts away, and then your jack pad rusts away, and then you have a big hole in the bottom of your car, which is where I'm at. That's the stage that I'm at with that. I can get a panel. I don't have a welder anymore. I think what I want to do is at some point corner my brother and be like, hey, I need like 4 hours of your time, like max, and just go to his house with some sheet metal, and we can just cut a panel. We can scrape away all the old stuff and then weld things back together. It shouldn't take too long, and he has got a good welder, so. It's a 528i 1999. Obnoxious. Okay, so now we need the other parts of this design. So what I'm going to do is I'm actually going to go new. Actually, no. Well, okay, so here's the thing. New package, right? Okay, this info pane is really annoying. How do I turn it off? What did I just click? What is that? Oh my God, something opened up over here. Oh, the Autodesk Assistant. No, please go away. No, please go away. I want you. Okay, component manager is what we were doing. What the hell happened here? Oh boy. All right, whatever. Anyway, we're in the component manager. Well, now my windows are all messed up. Close. There we go. Content manager. No, 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 no. Not keep right. Oh no, I wanted keep left. Or dock left. But then when I open this up, it's not changing this. What the? It's not changing that size appropriately. It should be. Okay, hold on. Yeah, it's the keep left is not what I want. There we go. That's what I want. Okay. Yeah, I broke the pin thing. We got it back, though. I just had to drag and drop it into that panel. Autodesk has its panels, and it ends up being like Steel Battalion, where you've got this tiny little view screen and a bunch of controls around everything else, especially because I squish it down because we have the vanity panels over here. So I'm thinking about, in the near future, if I can get around to it, actually do a like a VTuber in the corner, and then I can green screen out everything else. I like being part of the show, but I'm an ugly, disgusting engineer, so maybe I can put my chip boat in the corner and just make it into a little speaky thing that'll represent me. Is it a parallelogram deal like steering? It's something like that. The windshield wiper has this weird, complicated path, and it's got like 2 levers that come up to it, and somehow those coordinate the wiping action. What's up, Ryan Labs? Welcome to Twitch, where you get music, not right now, but during the intros and the bathroom breaks. Okay, so, yeah, so now that we've got this, we actually already have SO16 and a 3D model for an SO16. So while the button says new, it really, what it means is that I want to assign a new package. Hey, Madam, how you doing? New local package. We're not adding it from the web. And in this case, we're an LCFSP6. No, we're not. We're an actual SO16. So SO16, now I've got one without and one with. This is the problem, is that my stuff is a little disheveled, a little out of control. I need to kind of rein it in and make everything proper. 1, 2, 3, 4, 5, 6, 7, 8. So this is also SO16, and it looks like the package is, see, like that one's wider, that one's thinner. We want the thinner one in this case because we're trying to save space. We're trying to fit all this stuff into one design. I think this might actually be the way to go. So for the variant name, I'm going to do SO16 narrow. So here we have SO16 narrow. Now I can hit connect, and I've got all these pins that I have to figure out where they connect to. This is where we do the pin assignment, and everybody gets pin numbers. Yeah, Remdog, everybody's migrating over to Twitch. I'm doing more for Twitch by putting this on YouTube than I think that they owe me money. They should give me money. So, all right, so we got to assign this. So I need to actually pull up the data sheet so that I know what pin is what. So this is where these cute little diagrams come in handy. So VC, oh, okay, it's gone forever. I'm gonna put this onto another monitor. So you guys behave, because I won't be able to watch you guys. Don't do anything weird, okay? Okay, so P1, P2, P3, we need to redo that. I need to actually go over to the symbol, and I need to edit the symbol again. Now I can get to it through this. I can actually pull down the menu here and view the V2164, and I can hit edit. I guess I could just double click to edit. Oops, double click this one. There we go. So now we can actually assign names to these. So control, input, output. I mean, I could just do IO and C, but it's whatever. Time to roll ads. Suppressing my chat through ads. I try to turn off as many of the ad things as possible because I can't stand ads. So now we're doing this, and so now we can actually, oh, there's a slash on input. Hang on. I have to double click to edit, huh? I'm just going to do C. It's going to be a little bit less text heavy. I, and then this one's O. CIO. Save that. And now double click ourselves back into this, hit connect. And now we can actually assign them with CI and O. So on VCA1, control is pin 3. I hit connect. Append adds a second pin. So if you have multiple grounds or something, you can add them all at once, or add them all on one thing. I know Ryan Labs from Louis Rossman's Matrix Space in the All Things Repair Discord. Oh, that's cool. Yeah, we've had a brush with some pretty famous, electronics YouTubers. We've had Strange Parts has flown by our channel a couple times. We raided into a Louis Rossman stream, and they completely ignored us. So, Rossman's a cool guy, and he does a lot of really cool stuff. He's not great with the whole streaming thing, the whole live thing. And I don't think they do that anymore. Sad part is if you turn off the ads in the ad manager, it doesn't turn them off. It just turns them off. It just turns off your payout for them. I may have turned off that payout. Consider it blood money. Because I just have the pre-roll ads. And then when you actually sign up for the ads, they give you like goals of how many ads to run and stuff. And it's like, I just don't want to do that. I don't like that experience on Twitch. That's not the kind of thing we do here, you know? Is it revenue that I could be making? Probably not. There's like 12 of you guys. If I had like 1,000 people, maybe it would do something, but I just don't think it will. We're too small of a channel. And it's interesting because, again, I've had brushes with Louis Rossman, Strange Parts. There's some other creators that do know who I am. And then there's we got raided by Pendleton Ward once of Adventure Time. That was Oatmeal Man doing that, but that was like, I was not ready for that day. Oh my God. If anybody's left over from Pendleton Ward, I think the people who would watch him were in it for the art type stuff. So we weren't doing too artsy fartsy kind of stuff at the time. It's just crazy because you're like, oh, it's a cartoon that I really love. Here's my chance, and I blew it. VCA1 inputs, which is pin 2. Connect. VCA output 4. Connect. B control. So B we're going to call VCA2. B control pin 6. I control or input to B 7. Output 2 is 5. 5, 6, 7, 7, and I think that's correct. If I get this pin out wrong, that's gonna be embarrassing. I have a Tubro conscription. You get a cent every 10 minutes because of it. It doesn't make sense because I'm not paying enough for them to do that. Wait, what? 1 cent? Waiting for UPS to drop off chips to program. The factory work that the cool thing about doing electronics and the hobby stuff is that if you like repetitive tasking, you sometimes get saddled with an enormous I have 600 drivers that I need to solder this one pin onto. And you get to do that factory work for just a little bit, not until it causes you to have horrible carpal tunnel syndrome. That's the cool part. You're like, that was fun. I love factory jobs. And then you're like, wait, no, I don't, because I don't like repetitive stress injuries. Output from B is pin 5. Okay. I'm running off of this schematic, which is not the V2164 that we have. This is the SSI 2164. But I've been assured that this is pin compatible. Without checking in any meaningful way, I'm going to trust it. So A, B, C, D, we're basically just going around A, B, C, and D. So C, boy, rearranging these things to be the best one for the task is going to be tough. I like post-production correction job lots. Well, like tear up one trace on every single board. Ugh. C control pin 11. C input, pin 10. C output, pin 12. D control, 14. D input, 15. D output is on to pin 13. Connect. Oh, geez. Gund is on pin 8. Mode, pin 1. V plus, 16. Oops. Disconnect. V plus 16, and then V minus is on 9. Okay. Whew. So now we have a narrow SOIC package, which is good. We needed a narrow SOIC package for SO16, and that's our V2164 transconductance amplifier. It's a voltage-controlled amplifier, and it works on current instead of voltage. So when you're probing the board, you can't just probe it with the probe pin. You have to actually have something that's going to convert it to voltage. And so there's an op-amp circuit that does that, and that nets us 2 extra op-amps, and that way we can reinvert the signal if we need to. $12 a month that I'm paying Twitch to not get ads, and I watch way more than 200 hours a month, usually multiple channels at the same time. That's kind of cool. I would consider Turbo, but I think I really only subscribe to Roboz. These have the values there. Mostly I'm fodder for people to gift their favorite streamer a subscription, which I'm totally fine with. That's a good role to be in. Okay, so this is all done. Save. And now I'm going to go into manage, because I have this stuff managed on, what do you call it? I have this managed on Library.io. Library.io used to be able to share all of your library stuff. They kind of closed it off. Yeah, well, it's the partner badge is what gets me that status. People go, oh, look, it's a partner. Okay, do partners get ads? We used to not, which is good, because we're Twitch's product, right? We're the product. We really shouldn't get ads, but we do now, because some fucking executive probably decided, hey, we have a lot of partners. If they see ads too, we'll make this much money off of them. Like, this is the soulless fucking decision that came down from an executive. I need a haircut. I don't know if I'm going to be able to get a haircut because it's getting towards the holiday season. All right, anyway, we got a part now. We got a new part. But I need to actually upload this. So push changes is basically the up arrow button. Press that. That's going to say, oh, do you want a new version of your library we created? Any 3D packages uploaded through the web will be retained. Create. So we locally created our package out of a part that we already had, which is a nice narrow solder pad SOIC. That's going to hopefully enable us to just place the part down with the current design rules. We're going to have to refine these design rules. I need to go right up against the limits of what is possible at this board house. So this synchronizes everything. It uploads and downloads. It does all that stuff. And now we have our 3-dimensional part with the pads and all the fun stuff around it. Hooray. Okay, let's go back into our schematic and let us place our transconductance amplifiers. So design manager, not design manager, part manager, place component. There we go. Place component, and we go all the way down here to the V's, and we have V2164. Look at how narrow that is. And we can place, oh my God, it's enormous. Let's go ahead and go into that symbol and make it much, much smaller. Let's go back into the symbol and make it smaller. We've still got the library open over here. Hey there, bud. Why don't you show me that symbol right there? That one. Yeah, that's the one. There we go. Cool, cool. How about we delete everything? We make it much smaller. This schematic is probably going to end up being a couple pages, but I'm going to create it on one page first. So what I'll do is just go over like this, and we'll do this many here. That way, Get rid of this. Bring you down. I mean, I could do it like that, but then it wouldn't be clear that it's the control pin. That. This. Going directly. And then, can I make it smaller than this? Oh, yes, I can. Symbols don't get jealous. They're uncorruptible. Just look at that documentary, Batman. Batman Begins, or whatever. A symbol can't be corrupted. Alfred, as a symbol, it can't be corrupted. Oh, the Christian Bale Batman voice is a trip. Let's see. How am I gonna do this? I want this to be nice and small. Very tiny little symbol. I want to go halfway up here, but I don't have anything to like guide me to halfway up. And if I want to do halves, then do it like that. Oh, look at that. It's a little baby symbol. Beautiful. Look at that. Perfect. It's perfect in every way. I don't know about putting value on ICs. I really need to go through and make like a style sheet of guidelines for what I'm doing in my my personal components, and then in a day go through and edit all of them so that they all adhere to my standard. That's sort of like a personal thing that you do when you build stuff like this. So anyway, let's save that, and now we've got our little baby transconductance amplifier that we can put in there. Julian's Absurd Volume Knob is just the working title for this design. I'm, of course, going to call it something else, but Julian didn't really like that's what I called it. But it is kind of ridiculous. It is pretty absurd. Yeah, and that's kind of what this has. It's got IC1D is the name, and then the part number is the value. Although it's got ADA4062, 4LFSCP16 is the package. So it's the IC the value is the part number, and then this is the package description. And see, this one says V2164SS16 narrow. And unfortunately, it says U1A. That's kind of really annoying that it does that. I don't know how to get it to actually not do the $ thing. I thought I gave it a, oh, you know what it is? I know where we can do that. We can edit that. We can fix it. We can fix it. We can fix it. What we didn't do was in the package manager, we go over to the V2164, open that up, and then we didn't give it a prefix. This little unassuming column right here. Prefix is U. Some of them say IC and some of them say U. I need to fix that on a lot of them. But now that I've done that, this will now have, yeah, the proper whatever. So save that. Let's push it. I'm always reminded of the Venture Brothers push skit that they did, where people were calling pooping having a push, and it's actually just like grosser than saying pooping. The writing in that show is amazing. But so when it says push on this thing, yeah, it's a weird way to describe it. My brain is just destroyed by early 2000s cartoons. that's my mantle. What the oh, little view thing messed up. Okay, so now this should be a fully functioning part. We can finally put it in now that we've gotten all of our I's and T's dotted and crossed in whatever way we see fit. So I'm going to place just a bunch of these things because we're trying to gauge sizing right now. We're not putting the schematic down necessarily, although we will move into that in a minute. I really wish I could have had room for 4 more op amps as clipping indicators. That would have been kind of neat to do. But I guess it's just going to have to be without indicator. Okay, so component manager, V2164. Double click, and we get a tiny little baby signal. It still says U1A. Yeah, no, that's correct. That's actually correct. So 1, 2, 3, 4, and then this thing. I guess we didn't give it too high of a swap level. I could probably make that a little bit more compact, but boop, 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 boop. Okay, so this is all of the chips that will power this thing. There are not smaller packages. No, that's one of the big things about using this particular thing. This for the quad transconductance amplifier, I have only been able to find in an SO16 package. Let me fly by this again just in case, because now you're asking, I'm questioning it. DigiKey V2164. Now they don't necessarily have these things. TSSOP is larger. I think. It doesn't get us much, but it might actually help us if we go to TSSOP 16. Maybe we should add it in. Let's add it in and just see what advantage that gets us. Can I get it from... Actually, it's Cabin Tech. Oh, no, I don't want the PDF. Hold on. Cabin Tech has all the cool audio chips. Well, literally the ones from Cool Audio, but also it has all of the interesting audio chips. 2164, DIL16, or SOP16. DIL is not what we're looking for. Dual VCA, single VCA. 3-channel. Nope. Analog signal processing. What's that? Oh, compressor expander. Oh, neat. I ought to look into some of this stuff for my my microphone setup. 6-into-1 voltage controlled mixer. There's no way I'd be able to fit that though. Cool. 4-quadrant multiplier. Oh, there's some cool stuff in here. This is a dangerous website, Cabin Tech. Dangerous website. I just want to know a little bit more about this. I see. So that 6-into-1 is not going to work for us because we're doing stereo mixing. It's a little bit more complicated of a task. Got it. So I got to see our Christmas cards today, the ones that we're sending out, because I had to go to my folks' place and we did a photo session. And this not sleeping thing is not working out for me. I may need to actually look into getting another CPAP machine after the Dream Machine failed me. I may need to look into getting a CPAP because I need to start actually sleeping right. Because the picture is my folks around the chair that I'm sitting in, and they look great. And then Willow's on my lap looking on, and she is always cute. You can't take a bad picture of that dog. And luckily, my dad's phone made a little clicky noise right before it took the photo. And so Willow was like, what? And so she is like the perfect corgi face. Me, I look high in the picture. I look high. My eyes are just like, hey man, like what's are we getting ice cream or something later? Like it's just squinty eyes. Oh my God, I need to get better sleep at night. I like go to bed at like 9 o'clock. I've been staying up too late doing nothing. You know, at the very least, I could be doing abiotic factor and putting lasers up in the rafters. That's something that I've wanted to do for some time, is make the rafters into Pink Floyd's The Wall, just with you know, at the planetarium, with just lasers up in the rafters of my base. But I haven't done that because I've been just completely executive overload at night. So anyway, back to V2164. The 2164s quad voltage, man, we got to play with some of these parts. These parts look like they're a lot of fun. The problem is I need to actually learn a little bit about this audio engineering stuff and like what is required, what filters I need, you know, things like that I just haven't thought about. I've been very surface level with this whole thing. So SOIC16 or DIL16 is all that I can find. These do not come in a package that is any smaller. We can check the data sheet to see if they actually list a different package. Like Cool Audio is the one that I bought. And they've got, yeah, surface mount and through hole, and that's all you get. What about SSI? SSI, I think, is the slightly more modern one. The specs are comparable, though. I would wonder about these things, these transients and the signal-to-noise ratios. But again, I don't think on those terms. No physical package information? Dimensions? Huh. 16 lead SOP is the only type? Or did I pass over it? Diagrams, 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 and then our data sheet abruptly ends. Fat keys. TM. Okay, so yeah, we don't have any other packages. There's no smaller than this, than what we have going into this board. So now that I've got those parts down, let's take a look at them in the 2D representation. So we have all of our external components down. We don't have resistors and capacitors in. And the power plug. We don't have the power plug in yet. We're going to have to do a lot of stuff with the views of the different layers to make it like comfortable to view and make it so that we can actually do the two-dimensional layout. And we might even be able to start on the two-dimensional layout today. There's going to be a lot of considerations here because we have less than no room. All right, let's see here. Let's switch over to 2D and see what we got. These are larger. Are they going to fit right in? Oh, yeah, that's really good. Look at that. And they can go practically anywhere, so they don't need to necessarily be killed by the prongs of the potentiometers. But yeah, we can put those right down front and center, and then we'll have room for the traces to go. Why are you not centering? Maybe it's an alt. There we go. It's an alt space. That corgi is a loud mouth. She is being loud. I think all the mixing stuff happens after amplifiers. So, don't touch those. Those are very specifically put into place. We also made narrow pads for everything, these narrow oval pads. And I hope those aren't going to be a problem with the board manufacturing. I don't think they will, but it's just one of those things you think about. So down here is our final output. That happens after one of these little jim jams. So this can come down here. We need to fit this in here. Oh boy. Where in the hell am I going to put everything on this board? Oh my God. Like these need to have a chip on them that'll be the ESD chip. And then I need space here for all of the resistors and stuff. I may have to use 0402s. Then where's power coming from? I guess I can put a 5-pin up here. So let's just look at the 3D board just to see what kind of space that offers. The chips are slightly larger. Push comes to shove, I just do a couple standoffs for a second board, and the second board will have all the mixer elements on it. That'll make my life a lot easier. I could even put in another op amp to have clipping indicators. That just means that a lot of pins have to go from board to board. So blah, blah, blah. It's going to look about the same as what we had before. It's just that this is... that's probably not happening. This is probably not going to be good practice to have an IC go over the top of something like that. So the only really good place for me to put these 2164s is in between the prongs of a potentiometer. This is absurd. It's just absurd. I do not know how I'm going to do this. All right, that said, I guess we can actually start piecing together the circuit. So let me get all of these bottom row things out of the way, because they will be rearranged differently as we get the circuit down. And all the circuit is doing, aside from giving us a master design diagram, is they are assigning what pins get connected to what with traces. So it's essentially just programming this pad goes to this pad somehow, and then you have to provide the somehow by drawing it in. Seems like a waste of space up top. Oh well. I don't know what will... I guess the LEDs are going to be in a holding pattern for now. Shame, though. I wanted to have clipping indicators. That would have been cool. Actually, no. We'll put it back here. We'll delete it in the schematic. All right, I'm going to hit save on that, and we're going to jump back to reality. Oops, there goes gravity. There may be a lot of component swapping, like gate swapping, that goes on here, because we have multiple different things doing the same thing, and we need to figure out, you know, what the paths are. OPA 4991, what is it, huh? What is the OPA 4991? Is it one of these? Opa, nope. Fusion needs to stick with CAD CAM, not user-friendly. I don't even know what that means. What do you mean? OPA 4991. 4-channel op amp comes in TSSOP. My brother in cripes, did you not just see that diagram? We are using the smallest op amps. Tiny. Right, I know Fusion, I know those words. Just, what do you mean stick with CAD CAM? This is our quad op amp. This is as small as they get, aside from chip on board. It's the V2164, the quad transconductance amplifier that we cannot get in a smaller package. This is it. This is it for us. Which is really annoying because there's not a lot of room for traces on either end of this thing. What does EDA mean? I'm sorry. For some reason, I'm ignorant about weird stuff. The end electronics design amplifier. Amplify the design! I don't know. So it's Eagle. Eagle's the design package. Is that the electronics design automator? EDA is PCB design. It's not. I mean, it's not that bad. It's just this looks clunky just because of my space constriction. And if I take advantage of some of the view stuff, I'll be better off. The only thing that I find difficult to do is somehow defining the cut-ins on the edges of the PCB. But with like the design rule automation and stuff like that, like that's all, it's pretty good. Eagle's way outdated in features. I guess I don't use anything else, so I don't know that. They're catching up. Like I listen. This is hashtag AutoCAD ad. I am not being overly positive about them. I believe that they could do a lot better, and it seems like they are catching up on those features. They're catching up. It's, you know, they've rolled this entire new CAD program into their software. It integrates really well with the three-dimensional board creation. It makes very pretty, you know, AutoCAD is very pretty. It makes very pretty designs that you can then, you know, design structures around, figure out where the screws go, you know, make a front panel that you're going to 3D print, stuff like that. I find that to be very easy and intuitive in Autodesk. In Eagle, if we're still calling it Eagle, in Fusion Eagle? In Fusion Eagle, there's still those leftover, like, Eagle-y stuff. You know, all the stuff we just did, the part creation is still very, very clunky and less than intuitive. When you get the algorithm down, I do this, then I do that, then I do this, then I do that. While it is still outdated, clunky, sensitive, it can break pretty easily. If you stick to the steps and you press the right buttons, it works pretty well. And I was able to create that part pretty quickly and intuitively while talking to you guys. I miss Eagle when it was still Eagle and not AutoCAD. It was just kind of an eclectic piece of design software back when everybody was still figuring stuff out. I didn't have any particular love for Eagle, aside from the fact that you buy it and you own it, and all the hobbyists loved it. You buy it, you own it, you use it. In this case, it's a subscription, and it comes with, you know, Fusion 360 attached to it. It still very much feels a lot like Eagle. There's little things that are starting to leak in, because Autodesk is a really, really good sketching function. Their you know, system with sketch lines and you know, the property lockdowns of like right angles and stuff like that, and the snapping functions that it has are really good, and those are starting to bleed into the part creation. You saw when I was laying out the schematic symbols, there were, like, you know, little center icons and stuff like that that are the way that Fusion does sketches. I'm hoping more of that bleeds in, because that really helps out a lot. It really helps you make symmetrical, you know, schematic diagrams very quickly, symmetrical schematic component symbols very quickly. Sorry, my language, it's not super hyper specific, and it probably should be. Okay, so Julian's Absurd Audio Knob. We've got all of the major components in. We need to start kind of arranging stuff into their appropriate functions. These 3 LEDs we're going to delete. That's not what I meant. Boop, boop, boop. All right, so R1, R2, and R3. So R1 and R2 are going to be our volume knobs for each of these. Let's just put them on their own thing, I guess. This is coming on over here. 1, 2, and 3. We're going to have each of these is going to go into one of these guys, and then we're going to have those go out of control. So I guess I need to make a schematic diagram somewhere else. I'm just going to make that over here. And we'll just line up components for the rest of them. Most free EDA software, KiCad and Easy EDA Pro, has 3D modeling of the PCB, but lacks the other CAD, but allows you to export the model and use Fusion, etc. to do assembly. Yeah. Yeah, I guess KiCad is where everybody's been doing their CAD. All right, so I'm going to take this guy, flip it again, just so that our positive is going down, just because that eases our drawing a little bit. So before I connect that, I'm going to need a couple things here. I need some resistors, and boy howdy, I have no idea what I'm doing with capacitors yet. But let's just go to components here, and we're going to go to schematic managed. So these are just schematic symbols that I like to use. So GND for ground, that is traditionally, in my own parlance, that is just a hollow arrow. The hollow arrow representing ground. I just like it. It's neat. That's how I do it. So there's our ground connection to the first IC, and we've already hit the ground running. Look at us. We're doing an engineering. Here I go. I'm engineering again. Okay, so we go down to components, and this is where things get a little weird. We got to go to resistor, right? But we're not doing a 1206 resistor. We're not doing an 0805. We're not even doing an 0603. These are symbols that I have not played with yet. I do not know how this is going to go down. We're doing an 0402. I'm doing an 0402, and I'm going to regret it. I probably should be working with 0603, because that is the last of these sort of usable sizes. Let's just look up real quick. I want to look up a 2 HP mixer, and I want to see that other design that we were looking at before. 2 HP mixer. There was a design around here somewhere that was very dense indeed. I love how 2 HP mixer is coming up with eurorack, but it's also coming up with cement mixers and professional kitchen mixers. So they've got their right angle. If I look up 2 HP, 2 HP is a company. So 2U mixer. But that's 2 like regular rack. 2 eurorack mixer. Then it comes up with big things. Data sheet, any guidance on wattage? For what? So this would be like a big, that's probably going to be a very simple circuit board. What came up the last time we looked this up, there was some design that was very dense indeed. And I think it was the guy who went crazy and put a whole diatribe on his website. So I don't know if I can find what that search term was, but we saw the bottom of the circuit board, and it was an incredibly dense design. Yeah, no blenders. All right. Well, anyway, we got to start translating this thing into our schematic diagram. So basically, I'm putting these things down. I don't think I'm going to have room for 0603. If I start with 0402, that's going to translate all the way to the end of the design, right? That's always going to be what I use. If I use 0603 and I make it work, I don't know if I can make it work. Oh boy. This is tough. The whole point of this design is to go as small as possible. But I'm gonna actually, crazy guy who made super dense amplifier. I could do that. It would probably try. Well, this thing has been powered on for quite a bit. And thermally, really the only thing getting warm is the 2 chips over there. We're just pushing voltages around, voltages and currents, and we're not really doing a particularly large amount with them. I think that wattage is probably fine. In the potentiometers, I've got a total of 70 kiloohms. So 24 by 70. This is a total of 24 volts. So V is equal to IR, or wattage is what? 24 by 70? 1600 watts? No, that's not right. That's not right, is it? But we're not, I mean, I'm not, the total amount of milliamps that's going through this is less than, what, 30 for this whole design. So I'm not really concerned in, 1/16 versus 1/10 of a watt. Yeah, I'm not doing that. I'm not doing that. I do want to do a flex PCB for my keyboard project, for the Raspberry Pi Pico keyboard. Because, like, the Pi Pico, I could have an adapter board that goes just off to the side where it's got basically a square cutout with edge pads all around that square cutout. And so that I can overlay onto where the other chip went and then solder all the pads down. And then that'll be my keyboard, my code 10 keyless takeover. We got to work on that at some point because there's a couple cool things that I want to do with that. I had a dog hair just go right into my mouth. As I'm talking to you guys, I'm like not even breathing in, and it somehow manages to plug a dog hair into my face. I don't know. Buying a Pico is just the chip, but then I need all the support components, and I don't want to put this together. It's going to end up being more expensive than if I just use this, because this is only $5. It's like, look at all the shit that I need to put on it. And while I could do a minimum amount of stuff, it's still Needs like, it needs its clock, it needs all the, I don't want to deal with this. By the way, this is 0402. There are smaller on this board. 0402, that one right there. It may not look that small, but when you have to work in that size, it gets really annoying. Trace width impedance to part, sometimes 0603 is better. We're so cramped with space. This is going to be just another point that stresses me out. All right, so I guess we will do 0603 because they are human solderable sized components. So let me get the components down and resistor. We're going to go with 0603. Probably going to regret it. So that's this one, and that's this one, and that's this one and this one, this one and this one. Yep. You really don't want to go thick trace to small part. I don't know. For audio frequencies, I don't think we need to worry all that hard about this kind of thing. Maybe that'll bite me in the future, but right now I'm just kind of doing the seat of the pants. I have had too many people coming to me with electrical ideas lately, and I'm about to go on a diatribe about that. I have a great idea, Bother. Couldn't you just... No, I can't just. You can just. All right, back to schematic symbol. B plus, like so. And then I need a VCC, and that's going to be... Actually, wait, no, I made one. I made one for this. VNeg. My negative voltage. There we go. Microbots.io? No, I'm unfamiliar. God, that's so annoying how it does that full name there. Okay, so we need to now do this, and we need to name this one, and this one's going to be, I guess, RL1. Why is that all the way over there? I can't even grab onto it. Weird. One. Move everything into the approximate location. Hit copy a bunch of times. No, that was just the letter on it. Oh my God. I can't grab the right stuff because I'm too zoomed out. There we go. Just want to keep everything nice and compact. We've got a lot of schematic to go down. We do that one. There's a little bit more space. Oop. And we're not even sure if these are the best ones to choose, the best gates, because it depends on what's in proxy to what. So while we're getting this down, we are getting the main, design elements down. This is going to be altered later on as to what specific pin goes where. Okay, and this one is RL2. Name RL2. He's a wizard with PCBs. That sounds cool. Copy, where's copy? Edit, copy, this whole thing there. Yep. RL1, RL2, and then we can do RL3. No, no copy. I'm still in the copy thing. No copy. Don't copy that floppy. This thing in here. This thing up here. Let's just make our little gate. I'm not PEE. For 30 years doing repairs, making some PCBs, I learned a lot of lessons, see a lot of design mistakes. I mean, I've been doing PCBs for a long time, too. Long time. Using this program. You can see how fast I am with it. Oh, that's a little... You can move that in. Okay, and then this could have been a cut and paste. Probably could have saved myself a little bit of time if I cut and paste. And then name that. Name vol. We'll put an underscore C on those. Actually, that underscore is getting in the way of my lines, so maybe we'll just call it volume. Use Eagle back in the late 90s? Eagle was not recognizable back then. I used it in the 2000s, but back then I was using PCB123. Two of those products are ESP32 with USB-C. That's pretty nice. LiPo BMS, light sensing, proximity detection, and 9-axis motion fusion that's about the size of a penny, and a tiny brushless motor built from coils and a PCB with integrated controller. Oh, that guy. Yes, I do know that guy. I do know that guy. I saw the video about the PCB, the motor. I was interested in that chip that he used because we designed an ATtiny85 full. Sorry, there's going to be weird noises. Hold on. We designed a full RC H-bridge motor controller for a brushed motor just when I was doing the 1/24th scale RC car stuff. And I programmed the ATtiny85 down to its ones and zeros. So we were using the special timing registers and everything to great effect. We actually got it running and working as an RC car. There were some weird problems to solve with the microcontroller to get all the timings right. But we designed that and we used these awesome, like super high tech, very, very small transistors that are like super nice and powerful. Really, really cool. Put it all together, got all that software running. Everything was glorious, made a brilliant little PCB with it. Everything was going great. I hook it up to the motor and it doesn't do full throttle. It's unable to do full throttle for some reason. And I just went, nope, I'm done. And just that was the end of that project. That was a fully indulgent project that I did sort of in the wake of Burn the Subs filling up. And there was a lot of, I was able to bring that PCB into CAD and put it directly on the RC car and figure out how the fitment's going to work and everything. That was a really cool project. And it was taught me a lot about using the ATtiny85 to its fullest. But at the same time, I totally failed. Oh, wait, we need resistors on these. So rip up. Do we rip up anymore, or do we just delete? I guess we just delete. So these are the tuning resistors, and these I may have to order like very specific resistors for these, very specific valued resistors. But how do I want to represent these? I mean, in terms of like a schematic, it really should go up and down. But in this case, we're kind of space restricted. So maybe I'll just put them like this, and we'll do a copy of R4, and I'll put it like here and here. I even had those chips that are supposed to boost the trigger level. It's supposed to like pop off the what do you call it? The transistor, like fully hit it with a higher voltage to get it to kind of trigger. I'm doing this to make it compact. It's just going to be a little bit weird. Maybe I need to rearrange that a little bit. Or should I just, yeah, I should probably just make it full and stagger these, and that'll be one page of the schematic. Because it's pull up and pull down. I need it to be very clearly that. That just takes up so much room. Oh. What's going on? Weird is good. What soldering iron do you have again? It's the Pace ADS 200. Pace, P-A-C-E, ADS 200. It's real good. After Rhinelab's revelations about Hako, I'm curious what other mid to high-end soldering station. So this is like a $300 soldering iron. It is a giant coil inside of there, digitally controlled. You don't have user profiles or any weird crap like that. It turns itself off periodically. You have to hit the button on the front to prove that you're still alive, because you're soldering in bed at night and it wants to make sure that you don't accidentally burn down the house. It has $14 tips. These are about 14 bucks. You can get them on Amazon. They are quick switch. So what you could do is just pull this sucker out and then put a new one back in. Easy peasy, lemon squeezy. You get a special little pair of tweezers with silicone on it, or you could use something like, you know, wire cutters in order to pull them off. It turns on, it turns off, it goes into standby mode, and then it goes to sleep and does what it's doing right now and says off until I hit that button on the front. It is everything that I've ever needed out of a soldering iron. It works all the time, and it never doesn't work. And it heats up immediately. So here we are, cold. We're at soldering temperature. That quick. Which means if you plug this into a part of your circuit that requires a lot of heat, it's able to provide that amount of heat. It's able to actually put the pedal to the metal, put the pedal all the way down to the firewall, and actually give you that heat. Now, I had it set at 666, but it doesn't seem to like to let me keep it there. It goes back down to 650. It goes to the nearest, makes no difference. I got Hako's reply, but the AG is still anti-repair. Oh. Call Pace and ask them for a set of schematics. It's not all that complicated inside of this thing. And then I guess there are different tips that go into this crazy radio plug that does the soldering iron stuff. But you can get like the tweezers that everybody thinks are going to be useful. You know, the one in any experience lab, you find those tweezers and they're collecting dust. What if you got two soldering irons that are opposed to one another and you can use it specifically to move resistors? Well, how often do I need to move resistors? It's not that often. It really is not that often. Does it come as a 230-volt version you can use in the EU? I would assume so. I don't, you know, it's Pace. It's like a professional company. Listen, they don't pay me to give them praise. So your mileage may vary with it, but I've had nothing but a wonderful experience using the soldering iron for the past 10 years, 15. And I would still be using the original one that I bought, but this one was purchased by a viewer and sent to me. I had it on my wish list just because it was the newer version of what I originally had, but my original soldering iron is still sitting in the unfinished part of the basement, and it works. It still works. All right, anyway, not to totally plug them. Like, again, nobody's paid me money for that. It's okay. I need to convert these into this. This is a bit much, but this is the proper way to display it. Gotta like fold the wings up so that I can store it. Select and drag in one direction selects everything that is covered by the box. Select and drag in the other direction selects everything that's touching the box. And they are useful in their own little scenarios. Like, for instance, right now, I used one so that I could get that V-neg, and I missed it. Okay, so from here, doot. Oh yeah, and then I need ground on this. Components, Gund, BND, dynamite. And we'll probably have to give these their own pages in the schematic. I don't know. It's going to be a lot of weird stuff like that. Let's do it like that there for now. For now, I'm just throwing everything down so that I have, you know, the everything kind of displayed and get the idea down first, make it pretty later. There we go. That's what I'm getting at. ADS 200 in Australia, $800. Where do they get off? What the hell? What the hell is that about? Also, hello, Blue. We'll do a price check in just a sec. Let me just get this down. Okay, those are our three control inputs. I can't do anything too fancy with this stuff, unfortunately. Get the text here. That, and then we're going to do get the fourth gate, bring that over here. This is an entirely superfluous gate. I have no use for this. I have no love for this gate. So what we're going to do is just connect. Oh, did I reverse these? Haha, that would have been an issue. Hold on, got to correct this. Bonk. Bonk, bonk. Bonk, 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 and then we need the positive symbol down there. A little bit confusing. Some people go to great lengths to avoid that. They keep their op amps flipped, and it ends up being kind of weird. I like flipping the op amp. It just makes the diagram a lot more clean. But you got to pay attention to where the pluses and the minuses are, because that'll throw you for a loop. Yeah, all the bonks. I like that emote. Boop, boop. Center clicking is a little awkward. It's what you do in AutoCAD in order to mirror stuff. You center click on the mouse. So when you're clicking and holding something and dragging it around, you have to kind of like maneuver and click without it getting all stupid. I have a feeling prices have gone up since I got, like, man, we didn't know how good we had it price-wise. Everything's going up in price. I hate to sound like an old fogey in that regard, but I mean, it's like, I'm shocked at what some of this stuff costs nowadays. Okay, so there's our stuff. We've got it all aligned properly in the right things. Now, when you're not using an op amp, I believe what you're supposed to do is connect negative and the output, and then ground can just be left floating, or does that have to be grounded? Let's look at what they say in the datasheet. Save. That was a lot of work. So, you know, it looks like I'm just throwing down runes, but what I'm really trying to do is describe to the CAD program what is supposed to be connected to what. In the same vein, since I'm in CAD and everything's nice and neat, I can kind of start to tailor this to a design document that I can have in order to retain what exactly is on the board. This is exactly what's on the board. This is exactly what's connected to what. This is exactly what it, you know, blah, 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 blah. So if I get this and I decide to do an alteration, I need to make notes in this CAD program. This is now a permanent working document that's going to follow along with this design. Are there any other notable soldering iron manufacturers? Yes. Hako Paste, JBC. Oh, you got Metcal. Okay, never mind. Yeah, no, I think you got Metcal and Weller. Who makes that obelisk one? There's a soldering iron it's just this black obelisk that sits on the desk. I always love those because when my friends were using them, I would go, we'd all have to, bow down to the obelisk. Is that Metcal? Yeah. You'd throw up the 2001 moaning thing on YouTube. Play Mars. It's actually Mars, not Mars Attacks, but the planets, Holst's planets, Mars. Basically, we're going to do this. This is all the decoupling capacitors and stuff. But what I want to do is I want to look at the 80 blah, 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 blah data sheet and see what they say about unused amplifiers, because they usually have a little note about that somewhere around here. Metcal is great for monkeys doing repetitive tasks. No, you catch the bone in the air and it turns into a spaceship. That's what they're supposed to be doing. But yeah, the paste station I like it, and also this they don't sell these anymore, but you can find these. I mean, they're just little wooden tool chests. It's perfect for the paste station. I mean, you can see how, like this shop. You guys are lucky. This shop is the sort of culmination of many years of collecting stuff, stuff that works for me, and I am just your average hobbyist solderer that has a little bit slightly more professional experience than the average Joe. I know my electronics doodads and what works and what doesn't when putting stuff together. And so what I've found to work over the years has come at the end of a long reputation with trying things out. These are all tried and true and tested. So this thing over here, this wooden drawer thing, I don't know where you get one anymore because I bought this from Grizzly many years ago, but it is utterly the perfect size for holding little stuff and the helper stuff like the probes and all that probe handling stuff for the scope. And then the paste soldering station fits perfectly in the upper corner with your soldering reels and a bin of other accoutrement. The scope lives over there. I guess it wouldn't. They sell one of these that just has a big opening, and I was thinking about doing that, and then the soldering iron could go in the opening. But having the iron a little bit elevated from the desk is very useful. The scope, I guess it just lives over there. It would be nice to have kind of an enclosure for that was wooden. But yeah. FluxPoint EP5 is cheap, it works okay. Doesn't heat up fast like the Pace ADS200, but the 45 bucks I spent on it, yeah, that's a perfect price. And then when it breaks, you can get something slightly more expensive. How did you change the tip to change the temp? Is that how Metcal works? Weird. I was always wondering about that, because the Metcal was just this obelisk. I thought they were a different company, though. I didn't think they were Metcal. No, that is the Metcal. There's one that's like taller. I guess it probably is this one. But it's just this black obelisk that sits on the desk. So weird. Metcal. Anyway. Okay, so somewhere in this data sheet, as if they were trying to hide it, there's a recommendation for what to do with excess amplifiers. Phase reversal solution circuit. No, I don't think that's what I want. Phase reversal occurs in some amplifiers when the input common mode voltage range is exceeded. I've actually seen that in this setup before. I could use these. These are immensely smaller op-amp chips, but it's going to be a soldering nightmare if I go with that. All right. Control F, unused Not used. Used. We have only 3 instances of that word. Nah, okay. What to do? Good thing my O key works. Two. Oh, come on. What to do with unused op-amp circuit? Shut the fuck up, AI. How to properly configure the unused op-amps. Scanning electron microscope picture of EOS damaged device. Okay. Neat. It looks like it exploded. Multi-channel op-amps are often implemented in circuits that do not require the use of all channels. Undesired behavior, blah, blah, blah. Op-amp typically connects with blah, 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 blah. A whole bunch of information I don't need. Just tell me what to do. Tell me what to do, document. How dare you? So we do connect positive to ground. We do the loop and we connect positive to ground, and then there we are. And that just makes sure that there isn't like a situation where this thing gets some kind of a weird ambient trigger and causes it to like run away with current or anything like that. There may be circuitry in the chip that mitigates that, but we're just doing this to be nice. Why did they both move? Okay, and then I can right click on this and I can go invoke. I invoke you. And we're going to power plus minus there. 10, oh, pins 10 and 2? Why is that one a multi-pin? Oh, because it's the pad, I believe. The pad underneath is a no connect, I think. Let's double check that. Okay, let's see. So we are looking at that exposed pad. For proper connection to the exposed pad, refer to the pin configuration and function description section of the datasheet. It is recommended to connect the exposed pad to V-. Okay, so there we go. V negative, and then V positive. Okay, we'll just do it like that. So there's that one and the unused one. Cool. Very, very cool. No decoupling capacitors. I'm going to put that in later. I'm going to figure out, I still got to figure out what size that is. And let's make sure that we get all these connected. We good, we good, we good. Looking good. Everybody online looking good. All right, that's almost the whole page. I mean, I can probably fit a lot more on that one page, but this is the beginning of our drawing. This is our power, or sorry, our volume control knobs. So let's put that in its own little section over here. Let's move on. We've got more stuff to go through. The decoupling caps that I have are 0805. I mean, I guess I can do 0603 decoupling caps. Do I still have that part? Let me check. I think I've made all of those different sizes. So component up or component managed. They're going to be tall though if they're 0603, aren't they? Yeah, I described them in normal size instead of the weird ones. So yeah, 0603 cap. I guess we'll keep it all in the family. This. I could either copy it or I could run it over from there, but now we'll just copy it. How does Mutable do the decoupling? Hold on a sec. It should be 2 per chip because we're going to ground. Can Eagle generate a PCB from the schematic? I think, but it does do auto routing. I don't know how good the auto router is. I prefer to draw my own lines. And then, you know, we design the PCB in here where all of our components are brought over, and then we've got air wires that we have to resolve. And what I'll have to do is I'll have to switch around the views and stuff so that we're unperturbed by a bunch of the different, like, completely useless labeling that we get on some of this stuff. We need to turn off, and we need to simplify our view. That'll take a minute. Right now I'm trying to get the whole schematic down. Auto routers suck. Yeah, okay. Yeah, that's where I was at. I now have 21 and 24 singing Holst's Mars stuck in my head. Was it Mars God of War or something? Is the official title? What am I looking for? I'm looking for the mutable schematic. We have Mutable Instruments schematic up as an example because Emily Gillette is just an immaculate circuit designer. Her circuits are beautiful and just down to the brass tacks of what we need to put into our design. This one is a weirdo kind of resonant mixer where as you plug stuff in, it gets more complicated, I guess. It uses the V2164, so I've got it pulled up as an example. I don't know what to do with capacitors, though. I don't know, oh, look at this 220PF. We may have to do capacitors across our audio amplifiers. Emily is using OPA 1679. It's possible that I could find that in a QFN package, but the one that I chose because I was browsing the front of DigiKey, basically. I was looking around at stuff that had similar specifications to the TLS-74, and I found one. It may be lower noise. I'm not totally sure. I have to listen to that when I finish stream. So yeah, in this case, we've just got 0.1 UFs, so we'll do that. I'm not putting values in here. Values are for spreadsheets. Because if you want to change something and make it cheap, then you don't have a value printed on your board. Never print the value on the board. Only symbol names. And so if R12 and R13 change their value, I have the ability to do that in a spreadsheet, not having to print up new circuit boards. So yeah, we're basically just going to ground on this thing. Boop. Boop. And then we're copying or floppying. And I'll just hit a little copy. There. Yes, I want to make that thing that I made it. Yep. It's totally deliberate. Okay. Let's park that over here. Move this. That text is really annoying. Like, oh, you want the full part size and everything on your text there? So yeah, that's just our decoupling. That's the first leg of the journey. You can get a Hakko FX888. What the hell is that? You're just belching out Elon Musk's kids' names here. I would only buy this if it allowed me to just no picture. Oh, there it is. Only if it allowed me to put this at 666 degrees. I don't know. I'm not a big fan of Hakko. I don't like how sort of McDonald's they look. Everything is like soft lines on them, and I don't know. Pace though looks like it was built in somebody's garage. This looks like a project from somebody's garage. This is just a generic project enclosure. They had this printed up for them custom, but it's really not all that. It really does look like somebody built it in the garage. Yes, it's the Fisher Price. It's a bad station, don't get it. Yeah, I started working for the three-letter agency as a contractor, and they had their electronics shop there, and they used these paste soldering irons. And so I got the up close and personal, and they had a variety of soldering irons that were just ordered just to try stuff out. So we had the Obelisk, the Metcal, and the paste stations, and there were a couple others that I remember vaguely. There's, of course, you can see a Hako soldering iron from space. So there was a couple there too of the Hakos, and you see it and you're like, oh, there it is. It's the Maker soldering iron though. I'm sure they're fine, but the paste stations were above anything else in terms of heating up quickly, being usable, being a day-to-day soldering iron that's going to get you there. All you get is a temperature readout in front, and then the rest of the features are there for the longevity of the iron, turning it off and stuff like that. One of the things that I found that were coming out like back in the 2000s was you would have to have a USB stick with your profile on it. What? Like you unlock the iron with your USB stick, and it also contains all of your preferences. And I'm like, I have one number as the preference, and that's it. We turn these up to 700 though for doing the early formula of lead-free solder. We would use 700 degrees, and that would just make it much easier to use. Lead-free solder is good. It's good for you. Lead is bad for you, which I never knew was a controversial opinion. But apparently my chat is out here chewing on bars of lead. They're like, no, it's perfectly healthy. Lead is great for you. A bunch of Romans in chat. But the anti-lead, the no-lead stuff now has changed formulas, and they've refined it a little bit. It's much easier to use now. You do have to up that soldering temperature in order to get it to flow properly. And, use a bunch of flux on stuff. It's not that bad. And it's much better to not expose yourself to all of that lead, because it is very bad for you. Okay, so we know what to do with the old amps. We've got our decoupling capacitors in there. Those are 0603. They're going to be 0.1 UFs. We have our three outputs, which are the control outputs. Now we can get into the meat of the circuit. Now, one of the things that Julian requested was that this was normalizing. So what that means is the input that disconnects, P2, is connected to the signal line on this other channel. So we have to cross-connect them like this. What that means is that when we unplug the channel, it will send one single channel to both. That's it. I still use leaded gasoline. What is wrong with you freaking people? You guys are shocking sometimes. All right, so I guess since this is the meat of the main schematic, I'm going to put this in here. We do still need to resolve like what the power supply is going to have, but we might as well get to the actual like meat of this whole circuit. There's going to be a lot of repetitious structures in this. So I'm going to pull in our first IC, and I guess this one is going to be responsible for all four of the input channels. When designing this, I decided that I would put oh yeah, let's flip these. Go. So IC2A, we're going to bring that in over here. That's going to be our first channel. We got to move that down a little bit. Rhine Labs has a classic automobile, properly vintage. Oh, for an airplane. Oh my God. Ah, I just moved the whole frame letter. Man, I wish I had a properly vintage vehicle. I would love something like that. I used to drive around in a Volvo 164, which is probably not all that as vintage as people think, but it is a pretty old luxury Volvo. They basically took a 240 and they put a new front end on it. So half of the bolts were metric and the other half were imperial, which is great for a teenager. For a teenager to drive around. I had to have a full toolkit from day one. Let's go a little lower. So we're just gonna get these circuits down on paper, get everything in here, and then we can start figuring it all out. A 1976 Cessna 160. I assume that airplanes, when you get them vintage, they're in much better shape than a vintage automobile, just because of the propensity to actually care about the maintenance. I had a math teacher that had an airplane, but I never knew what kind. I'm not rich enough to know stuff about airplanes. Oh, that needs to go forward one. Boop. And boop. Let's bring these with it. So just getting the circuits down neat and organized, not putting any values in anything, or literally just programming a computer. That's our first stage. These are buffers. These are going to be unity gain buffers. Actually, they're 3-to-1 buffers. We are knocking the signal down by a third so that we're dealing with smaller, and maybe we shouldn't do that. No, I'm knocking it down not by a third. I think I put 33 in there just because. We'll figure that out later, but this is one of the things where we're knocking the signal down so that our mixer has the ability to boost the signal further up without distorting. So we want to keep everything plus minus 10 volts when we output it in the end, but I want to give a little bit of overhead in case you put a weak signal in here and you need to make it much louder. This is, I don't know to what end. I don't know. I'm not good. I don't know all of the ins and outs of audio engineering, but I'm going to run into all those problems along the way. And we'll hopefully learn some stuff together about what we're made of, and maybe what it means to really truly love. Nice and uniform. Let's bring this one up, and we'll do it again. Although I could probably just cut and paste. I could just copy everything, and it would infer and up these by the appropriate amount. The problem with doing that, though, is that these components here are very specifically locked into a position on the two-dimensional board. Our 69 E-type is in good shape, aside from it being a Jaguar and thus breaking frequently. The Jaguar that we took on the road rally, when was that? 2010? 2009? We took a Jaguar XJS on a road rally, and I think it was like a 70-something. I bought it from a guy in Maryland who didn't really do a whole lot of good maintenance on it, and also ran studs, but didn't run tapered nuts on the studs. He didn't have tapered nuts on the studs, which means there was a flat bolt and a tapered opening and a stud. And so significant damage to the spindles. We bought new spindles and it was fine. And then apparently, since Jaguar had a V12, problem with V12s is that there's a lot of moving parts. The problem with a lot of moving parts is that a lot of moving parts want to become a lot of broken parts in sort of very short order. And so from the dealership, you would pull in your XJS and they would take a Chevy 350 or whatever it is, your belly button jelly bean Chevy motor, and they would just simply swap the motor out. And so you got a factory motor swap for a Chevy 350. Now, we had the tractor motor Chevy 350. We did not have a good like carbureted one. I wanted to put in a good carbureted one, but we had a bit of a communications breakdown. My friend didn't know that that's what I wanted to do. And when I explained it to him after we had already done the engine swap, he was like, oh yeah, we definitely should have done that. Oh well. But the engine swap we did in a weekend. See, we thought this XJS was like all ready to go for the rally. And so we went to do sort of the final little maintenance things, like, oh, let's change the oil. And so we go to change the oil, and it's literally like a starscape. That oil had brass and metallic flecks in it, which is absolutely scary. This part number being as big as it is quite a hindrance to the size of my overall diagram. I guess I could just delete it, but I'm preserving it for now. We're just going to kind of scrunch everything down beneath the components here. All right, let's get power on these, which means stretching one of them out. We'll take the top one. Invoke! Where is that? My eyes are like fuzzy today. Gate swap. Oh, invoke. There we go. Plus minus. Just put that right there. And then we need V plus V minus. We can get that over here. I could hang the capacitors off of these, but I don't think that'll be a great idea. I'll just do this and that. And somewhere on the side, I'll put my decoupling caps. Come on, give me this. I'll put it like over here. Grab these. Actually, can that whole thing come with me? How are we with cut and paste lately, AutoCAD? Ah, we're pretty good with it. Not too bad. I have no room for it. I'll put it down here. Okay, so now for the first transconductance amplifier. That's essentially what the circuit is. This is doing the magic of the entire circuit. So each of these channels goes into their own little transconductance amplifier, and then we mix it up from there. Oh, uh-oh, something happened. So we throw this in here. I need a little bit of room for the control signal name. Yes, make that that. Okay, and then this comes out here. All right, so these are controlled by RL1 and 2. So this one is RL1. We invoke a name. RL1. Yes, make it RL1. That's what I told you to do. Name RL1. So this is essentially what this audio amplifier, what this transconductance amplifier is doing for us, is it is making it so that we can control RL1 as two completely separate channels. So RL1 gets the same control signal, and I actually need to come up with a circuit to balance the control, don't I? Although it should be the same, I don't know if we need to be able to tune that. So just leave that alone. These long part names are very annoying. I'll leave that where it was. Yeah, we'll just leave it like that. RL1, RL1, and then this one is, well, we need to add the name label. And then go to name. RL2. Yes, make it RL2. One error, you have to use the name tool in order to name the name. So name RL2. Yeah, so that's why it takes so many of these gates, is that we've got stereo coming in, and it needs to, oh, I see, there's a wire in here. Transconductance amplifier different from a regular voltage controlled op amp? Yes. So transconductance amplifier is controlling the current through the line instead of the voltage. Why they have to do it that way, I don't really know. I can't really answer that. But it's just what they use. Transconductance amplifier in order to control it, basically turn the volts into current and then make that voltage controlled. I got all the corroded vias, freaking tedious. What are you doing to repair it? Are you using like rivets to put them back in? Or is it like solder through? Pack that in a little bit there. Stage 1 complete. Guitar riff. Those will get their own circuit structure down here for power. Yeah, L normalized to R just means that if you unplug this, then that connection is going to be completed, and so it will end up putting both channels to putting your one input to both channels. Now let me double check that. If I plug something into J5, that means that the signal's going out J5 up to J4's P2 and then into J4's input. And then it's also coming back down to P2 where it's disconnected. Yeah, okay, that's fine. Clean hole, use a copper wire to connect both sides. Oh, so it's like real Bush League kind of repair type stuff. Don't you like buy the rings or something? I remember that as part of the process of getting my own PCB made was they made an in-house PCB. And so what the lady was doing was everywhere I had a via, she had a little ring that would go in and like a little ring expander. Okay, stage 1. Stage 2 is where our rights and lefts mix, and then they both get a pair of transconductance amplifiers. So we need right, and left routing. These part names are really getting in the way. They're really getting in the way. I mean, I guess I could just delete that. Yeah, we'll just delete that. Really just makes things so much nicer. And then if I want to, I can drop text back down in order to describe what the parts are. Get out of here with your giant part numbers, you piece of shit. All right, there we go. So much cleaner. Although I guess I could leave one for each part. Yeah, hold on. Let's Control Z a whole bunch. I'll leave one per part just so that it's defined. So let's go back to delete, and we'll keep IC1A just like that. There we go. It's the only place that's going to fit. That's the only place that's going to fit. That's really annoying. Okay, so we do our R's and L's. So R to R, L to L. So we actually need to like define these as right and left. Although I guess I can figure that out, like J2 and J3, figure out where they're placed and make those right and left and assign them that way. But basically it just means that this one and this one go together, and then this one and this one go together. Probably a better way to arrange that, but whatever, who cares? Who cares? Let's pull that in a little bit. Let's make that nice and neat. Smash that into itself. So 342 should go with that one, And then 1112 should go with this one so that it's the two sides of the IC. And we can basically just put this in here. Well, depending on the height of the op-amp circuit that we're putting it into, because we can move this over to here. And we'll do 2 of these circuits. So we need U and U. And then this is the second stage where we invert it. We haven't even gotten close to the headphone jack yet. We're getting there. I have a tube and rivets, but I'm not going to drill and enlarge. It's not worth it, I see. It's crazy. It's so much work. All right, so we copy this, bring it over to here. Actually, wait, I want to invoke the power. Invoke! Power there. Place that there. Okay. Get positive and negative on this thing. So a lot of this is like, how do I like to draw schematics coupled with, I only need this in order to tell the program what the air wires are doing. The program just draws a little wire and it keeps track of them for you, a little as the crow flies connection from component to component. And that way you know where you're supposed to route traces. So unlike when we're building stuff physically, I like to route power first, and then the signals can just go to wires that'll slink their way around. That is turned on its head when we design stuff on a PCB. When we're building stuff on a PCB, we want to do all of our signal routing first, because power can then slink its way around with its larger traces and get its way to your ICs. That's generally how I do things. I'm sure people do stuff differently. Everybody does stuff different ways. My dog, I am about to go fucking beast mode and yell at her because she's barking at the door and she doesn't stop. She's a very loud dog lately. I don't know. She loves seeing her friends, and that's usually why she's barking. Is she sees a buddy outside, and she's like, "I have to see my friend!" Ah! And just goes nuts. It's very cute when she sees certain people. She'll have certain reactions. So if it's the other corgis, she will do a boo woo woo woo, and her head goes straight up in the air like she's howling. She's already gotten to see them today, so I don't know if she knows how lucky she is. We're actually going to have the same circuit over here too, because we're inverting this. Oh wait, I messed up. Man, I miss my old CAD program. The CAD program that I really kind of cut my teeth on. I think it's called CirCAD, and it's so much faster because you have sort of these English language single button switches. What's that? Here I thought any amplifier controls both voltage and current for the output at the same time. Something about transconductance amplifiers, for some reason that's how we do mixing, at least in eurorack systems, because we've got a voltage control, the ability to control with voltage. And I was thinking about this for this circuit. I don't know if I'll have room or time or the ability, but I could have an add-on board that would give you the ability to control the 2 stereo channels with control voltages. It would be nice to do. And if I do that, that means that I need 2 more op amps on probably another board that would then interface with RL1 and RL2. And then volume would just be a manual knob. You wouldn't control volume overall. Okay. Yeah, not a lot of people going on. I guess big streamers are doing their thing. It's like, I don't know where to put this. It's such a huge block of text that takes up all this space. So we're putting in another inverting amplifier. Much to the chagrin of the amount of space that I've been afforded, I am indeed putting in yet another inverting amplifier. Now, are these correctly oriented? Yes, they are. Okay. Oh, and I forgot to put grounds on all of them. So when you get out to signals like this, when you've got everything attenuated to where you need it to be, it's just a matter of getting the phases in the correct orientation. And when you're working with op amps, that's as easy as adding another op amp. So what I've done is I've added another op amp, and that will give us the opposite phase with something like a singular microsecond delay, I think is what we measured on the scope, and that's not even, my scope probably isn't that accurate at that time scale. It's in that place I put that thing that time. But what that means is that we can then send a differential to the headphone amplifier, which I think it prefers. I think it's a little bit less noisy when it gets a full differential. All right, moving along, moving along. Alamarine. It's one of these. And that's going to go somewhere over here. I guess we can maybe put it up like that. And then we'll make another one of them. Whoa, or anything else. Boop, boop, boop. And then boop, boop, boop. And then that one goes into that one like that. This will go out here. And then we copy that floppy. Well, the R's and the C's are going to be out of order. We can always reassign the R's and C's at the end. There's a thing that you can run that'll basically go from the upper left to the lower right. See, with schematics, we're trying to communicate functionality. And so generally when I'm drawing a schematic and when I'm authoring a schematic like this, in order to describe the design of something, I'm starting in the upper left and I'm working my way down to the lower right. Now, there's all kinds of circuit structures out there, almost anything under the sun, and you can have a lot of violations of that sort of circuit structure. But my design rules, the way that I like to design stuff is you always put a dot on a crossing on an intersection. Always put a dot on an intersection of more than two. So if you have three coming in, you put a dot. You don't do four-way crosses, because if you happen to have a line that you forgot to put a dot on, so let's just say I'm not the most reliable narrator in the world. I forget to do stuff. This happens to me a lot. So if I forget to do stuff and the possibility exists that I forgot to put a dot on a four-way intersection, that can wreak havoc with your final design. So what I do is I never cross four ways. Never. So if something looks like this, that means that something looks like this, that absolutely means that I did not intend for this to connect. You don't forget to do a dot. Without a dot, it's not connected. No, you never do a four-way intersection. So there's never a scenario where you have four things going in with a dot. Dots are only for three-way connections. And if you have a weird scenario, obviously everything exists forever. There's all kinds of weird things that happen with circuits. Sometimes you have like a five-way connection, but avoid them. Don't do four ways. Don't do five ways. You just split your circuit up so that it has other junctions. Like you go in from here, and then you do another one that comes out from here. This is preferable to a four-way intersection, because if I've got a line without a dot that goes in three ways, like if it looks like that, that's connected. I just forgot to put a dot there. It's just a safeguard against confusion. All right, so these are doubled up. I'm doubling these up. So like that and like this. This is recommended in the data sheet. I have two extra amplifiers that just don't have any business in the circuit. These are all connected to one another. No, wait, no, they're not. What am I smoking? That, and then like this. It's all these, the control signals, that are connected to one another. So those will just be assigned to Valhalla Hetta. Menvurifala. Let's do name on this, dude, and then we'll put that right there. Whoops. And what I could do is I can go to the wrench dialog. which is the change tool. That's up here. Where's that change tool? Oh, no, I guess I can't. Huh. I can just do the name tool, I guess. So there's a wrench tool that can let you change the property just by clicking on it. I guess I don't have that. And it doesn't let you do it in here, does it? Yeah, it doesn't let you do that. You have to use the name tool. Silly. Well, name tool is just on the letter N. Oh my God. Okay, user interface N, U, all, yes. You got to hit escape to get out of the tool in order to move stuff around. A lot of slamming of the keyboard with AutoCAD. Slamming escape to get out of a thing. I don't know. Other CAD is probably like that too. So that's in the editor, but if you're talking about schematics that you're drawing, if you're making design documents and stuff, I keep that in my CAD program. I know the dot indicates in the CAD program that the two are connected, but the way that I draw, there's no possibility of that. And like, for instance, if there was some weird setup where you're coming like this, right? It can look like something's not connected or supposed to be connected or just confusing. So this is just like a general piece of advice. Don't do four-way junctions ever. Just don't put them in the stuff. And if you do that, then you can be confident that two wires that cross aren't supposed to actually be connected. I know it's not going to happen in the CAD program, but you know, anything can happen. What made you choose Fusion over KiCad? I cut my teeth with like PCB 123 and like all those MS Paint style PCB editors back in way back in the day. Those are the ones where you use their little editor, you draw your cute little diagram, and well, even before that, you didn't even have a diagram. You just put down footprints, and then you would connect them manually using an MS Paint style editing program. You'd send that in, they'd send you a board. It wouldn't even have solder mask on it. You could put your circuit together for relatively cheaply. It's like $100 for an order. Then I used Fusion for a couple PCBs, not too many. This was before $5 circuit boards. Then came $5 circuit boards, and I started to mess with some other CAD programs. I didn't really like them. We used CirCAD at work. That's not a very comprehensive program. It's like one guy making that entire thing. CirCAD was just a way to make pretty looking schematics. From there, I used MS Paint to make schematics using pixel art. And then moving forward, I decided to get a professional copy of Fusion Eagle. And so I had a client at the time that paid for it. They were happy to. I made a couple circuit boards for them, and then they effed off because they hired their own circuit board person to come in and design their electronics. And so from there, I just knew about Eagle, had my copy. In parallel to that, freshman year of college, sit down in front of a computer at a class, and they said, this is how you use AutoCAD. Here's the command line interface. And so I learned AutoCAD early on and the methods of sketch and extrude. From there, I looked at Inventor a little bit, and it turned out that Fusion Eagle was a thing at that point. So Fusion Eagle, well, those are the two programs that I used to design stuff. And that's where I sort of went forward using these programs. I did not know of the existence of KiCad. I did not know about any of the other programs that people try to push on me. Everyone has their flavor of, you know, diagram stuff. They have their own flavor of whatever CAD program they prefer to use. For me, Fusion Eagle, one program. I get to do sponsored segments like we're doing today. And that's it for me. It's free-ish. I would be using it anyway, so, you know, might as well just use the version that they give me. And I found it to be a pretty looking program, which is good for stream. For stream, you need something that's going to look good. So this program appropriately looks good. You know, you want to wow people with how cool your diagrams look. Well, with how cool the 3D PCB looks. I know every program does 3D PCBs now, but I find Fusion's brand of CAD to be easy on the eyes. Do I really want to do it like that? I don't think I do. It seems kind of like slung under. I guess that's okay. That appropriately communicating. I think I want to move this out just a little bit, give it some room to breathe. Like that. And there's our R's and our L's. Move these up like this. And you know, when you get used to how the CAD program works, I mean, I literally made this part in the span of like 10 minutes with you guys strung along. So I'm explaining everything that I'm doing as I'm doing it. It takes more time. Seen so many schematics with four-way junctions, black and white ones, like the ones for my Iliama CRT monitor. If it's connected, it's a dot. I'm not arguing that it's not. Minutia. On a schematic diagram, if two lines cross and there's a dot, that symbolizes a connection. Yes, nobody's saying it doesn't. What I'm saying is in the schematics that I draw, and it's something that I think you guys can benefit from, is having a rule never to have four-way junctions. Don't draw them. Don't use them. My eye twitches when I see people using them because I've seen a scenario where the author of the schematic forgets to put a dot on the two-way junction. And so you're like, well, those aren't connected. But then it turns out that they are. And that's a big mistake. It's a big mistake and it's hard to detect, which is why you never do that kind of junction, and it saves you from that question of, well, did they mean to connect that? Maybe they didn't. That's what I'm trying to say. That's what I've been saying. And if you misinterpret it again, you don't understand what I'm saying. Horseshoe over. I hate the horseshoe so much. The horseshoe is like from the ye olde days of breadboarding under candlelight, where it's a literal breadboard, the board that you put bread on. Whoa, 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 wee wah, wah, wah. What was happening there? All right, you let go of that. We're going to move you up a little bit. I mean, I guess I could just move them both up. Nope, I want this one. There we go. It's just that text that's getting in the way, and I can move that. God, just the giant block of text is really visually unappealing. There. So I'm just being space efficient here. No, back down you go. Okay, so there's our stereo coming out here with the volume control on it. And then from there, we have our... Oh no, this is not the circuit. This is wrong. this looks like this. So that's going to 100 PF and then a 2.7K resistor. So those are gone, and then we need capacitors on top of this, which means I need to move it back down. So there's more fiddling. More fiddling to do. We'll bring it back down all the way over here. Try to go for like the middle of that. Then it kind of looks like a thing. Sure. Sure, bother. It looks like a thing. You're very correct. Okay, and then we're going to copy our decoupling capacitors because it'll be an 0603 sized pad. I don't know what the final size of the cap's going to be, but it should be able to fit in an 0603. This one is correct because this one is just like a unity gain amplifier, but this one is attenuating and turning current into voltage, which is why we have the capacitor is I believe actually the cap might just be there for frequency stability, which is something that I need to add to all the other ones, to be honest. You need to add a whole bunch of capacitors to each amplifier chain so that we can filter out high frequency transients. High frequency transients. Doink, 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 doink. Go. And then we doink this to the doink over here. Doink to doink. Oops. Let's get rid of this segment. And doink this up here. Like that. Okay. And then this one. Get rid of the segment. Doink it up. This is basically what you're watching right now is the process of transcribing an entire schematic from my napkin notes. What is that? What is this? And again, look, I was able to identify it as a mistake because it was a four-way junction. You see? See why you do this stuff? See why you do this stuff a particular way? It's very important. We'll leave that unconnected for now. Started doing fusion. I've been doing fusion. I've been doing fusion for my whole life. I've been using this program for so long. So long. I've been using this since Eagle. I walked into college and they sat me down in front of a Windows 98 computer and they said, boot up AutoCAD and open the command line. It's the first time you've seen me use it. Yeah, it's been a long time. But yeah, I'm very familiar with the way Eagle works. I'm very familiar with Eagle. You can see by the speed by which we've been able to put down an extremely complicated circuit. Of course, having worked with this circuit for the past month also means that I kind of am very familiar with what's in here. I have been kind of hitting my head against it for a while. We can see over here that I have the full circuit has come to fruition. The full circuit here works. So I have overall volume control. And then I have right channel control. Well, I have one set of rights and lefts in one control. No, it's one pair of right and left in one control, and then the other pair of right and left in the other control. And they're mixing into stereo. So each stereo is a right, and the other one's a left and a left. But the right-lefts are controlled with this is very confusing. But you can see the mixing of the channels here. It's a little glitchy because this is a solderless breadboard. So we're trying to get our Rev 0 or Rev 1 of this design together because it's going to make it's going to be a lot more stable and testable if we get it all together onto a board. And then I guess I can figure out where I need to sprinkle capacitors in order to keep it functioning. But yeah, this is sort of the very first blush of a circuit board. We've already done kind of a little bit of size layout using Fusion's 3D PCB technology. All of the CAD programs have this now, but it's good to be able to put actual components down and figure out how you're going to fit everything onto a 10mm by 100mm board. It's not looking good for me. There's a whole lot, there's not a whole lot of real estate, and there's a lot of chips that are going down into this thing. And I'm trying to think of, is there like a better way for me to do this? Is there a more efficient way for me to do it? But if I do that, then I lose sort of the professional quality that I'm trying to bring to this mixer. We're using a professional audio amplifier as the last stage, which is kind of the thing that we need to put in now, and I don't have a part for. Why do you need to fit everything in there? Because if you get your PCBs under 100 by 100 millimeters, they are $5 for like 5 of them. This is the new like hobby scenario. Like these $5 circuit boards have completely ruined the design process for the old school people like me. I know how to put together like a perforated prototyping board. I don't need to anymore. I can just make a PCB, order it, and go, oh, this is wrong, this is wrong, this is wrong. Boop, 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 boop. Send me more PCBs. That's what we're gonna do with this. That's how like every project should be from now on. All of that because I can take the eCAD over to the normal CAD and just design an enclosure for it in Fusion. That's the thing, like with Fusion Eagle, and Eagle is on its way. I mean, there's like, Eagle has existed for a long time, but I've found the price jumps by like $20, which I guess can discourage the hobbyist. I try to keep it under 100 by 100. If we really bust our ass, I think this design will fit. But yeah, so the Eagle is not that bad. It is fairly complicated. It gets the job done. I'm used to it, and you can see how quickly that I can work with it, even while streaming, which while streaming means that I need to talk about literally everything that I do. Every single thing that I do, I try to tell you guys about. I try to think about, well, what's the lesson behind what I'm doing right now? And that's streaming. That's just how you stream stuff. It's like having a trainee following you for everything. So I try to teach you guys as I go. It takes a lot longer. But if you know the processes, you know the steps that you're supposed to go through, you can do stuff very efficiently with Fusion 360. It's pretty nice. Yeah, you can also use KiCad and export to Fusion. Fusion allows you to just like throw 3D solids up on everything. It's beautiful. Thinking about building a keyboard, but the PCB gets really expensive when it's full-size 104. Yeah, you got to shop around. I'll bet you there's some PCB places that would accept. You know, I think that's why a lot of people are doing split keyboards, is because you have, well, no, but then you have two designs that are going, I don't know. We need to do, in Fusion, we need to design one of those flexi orange PCBs, because I'm itching to get my spare keyboard moved over to the Pi Pico design that we did with the Maxim chips muxing. Because what we can do is, instead of the driver chip on the code 10 keyless, I can use an orange flexi PCB and have a square hole that's surrounded by pads, and then I can solder to the chips pads, and we can have access to basically the whole keyboard that way. I think that would be really, really cool to do a little orange flexi PCB that just has this thing sort of bootstrapped onto where that other chip would go, and then maybe like a power plug or something like that. That'd be really, really cool to do. I'm thinking about it. I really wish that this was USB-C though. I don't like that micro USB. But those Pico Pi, RP2040 Pico Pis are like, they're so inexpensive, it's great. So we have one more amplifier to go in here, and that would be the headphone amplifier. Vortex Zero, hey, thank you so much for the sub. And that's a Prime. Hey, if you guys have Amazon Prime, Jeff Bezos is not gonna remind you that your sub is up, so check it out. You get a free sub with Amazon Prime. Ermagerd, Amazon Prime. All right, this is looking good. We may want to add capacitors to, whoa, what happened here? What did you do? So we may want to add caps to all of these amplifiers just to knock out high frequency noise. We've got them on this one. That's just the way the circuit's done traditionally. I'm debating on whether or not I want to do that at this point. I may not. I'm not sure. So the new Picos have USB-C? They probably do. I mean, everybody's moving to USB-C now. All right. So this is our stereo jack. This is the green. Whoa. The green stereo Donkey Kong, the mythical green stereo Donkey Kong. We need one more part in order to make this thing work. And actually, you know what? We're going to work on that tomorrow, because I've been streaming for 4 hours now. I've been going for 4 hours, and we've got a lot of really good progress. I've got my controls up here. Let's actually move that down so that it's closer. It looks like the main meat of the schematic is going to be 1 page. And we can probably sync a power supply design down here. Power supply is just going to be a 5-pin header. It'll be a single row 5-pin header that I'll have to mark stripe on, and it'll be possible to plug it in backwards. So I'm going to have to put diodes on it. We have a part that I can put in. I want a big board. If you only need a single side, double side, you go do the board yourself. I've never had great luck with that, and I don't like the quality of the design when I am involved in it. You know, the board houses make immaculate boards. You can do a design yourself. Yes, there are plenty of ways to do it. If you're like Bad Obsession Motorsport, you could turn your 3D printer into a trace printer, which is a weird way to do it. It seems like a very automotive way to make a PCB. I wouldn't suggest it because you could just go to a board house. These board houses are making larger boards cheaper, and you get a fully professional board. UV lasers to do the traces. That sounds like you get a lot of pretty good quality out of that. Yeah. But like having acid etching solutions around and doing that is like, I'm going to build a PCB, ha ha ha. Whereas like you get to the professionals and we're like, we're going to have somebody else make the PCB. Like why? It's not good. Like just get somebody else to do it. They can deal with all of the difficulties. And the batch processing means that none of us are going to be out too much money. So I think if you shop around properly, you could probably find a place that would be able to do it. Like Osh Park, I think, is decently cheap for larger PCBs. I don't know about keyboard size, though. I mean, obviously forums exist, so it's likely that you would be able to very easily find. If desperate, we'll use my fiber laser. Can't conduct if there's nothing there to conduct. I know somebody wanted to, back in the day, somebody wanted to experiment with the Ruby laser out of an M1A Abrams rangefinder in order to you know, conflagrate or deflagrate the copper. All right, I'm going to save this like 500 times because I don't want to lose all this work today. What we've done so far today is simply to program the 2D PCB with the air wires, and it's just placing components down here further and further down and just adding air wires. Oh, it looks like our capacitors have a little keep out area around them. That's going to be annoying. Buy a CNC router for $100 to make the circuit, or a photolithography and etching is also, it's not that. Like, if you're just starting out, those are things, if you're building circuit boards a lot, maybe you want to look into. But if you're doing the CNC router thing, that means you got to do your vias yourself, you got to do your solder mask yourself, you got to do a lot of spraying and printing, and you have to have those chemicals around. Having a board house build the board, even if it's $100, $200, like, it's just a better route. You just check over your work more. And then you get like a completely professional circuit board. I don't know. For me, for my money, I'm not doing anything in-house. It's just not worth it. It's not worth it. Not worth it. This is a lot of stuff to fit on this board, huh? The board manufacturer is not the DIY part I enjoy. Yeah, building it is a lot of fun, actually. It's a lot of fun. Designing it, similarly fun. I enjoy the artwork of the whole thing. Making a PCB, dealing with chemicals, doing all that. Nah. No thanks, I'm good. Yeah, just because like you go to these board houses that do batch processes and it's dirt cheap compared to what it used to be. I think there's no real reason that you would super duper want to immediately invest in in-house board capabilities. All right, that said, I'm gonna wrap up now because I'm tired. We're gonna come back tomorrow. We're gonna build the final part, and then we're gonna start looking at the PCB layout, and it's gonna be painful. It's gonna be painful. So far so good. Our schematic is going down. There's maybe a couple little elements that are missing, some capacitors here and there. I don't know about what capacitors I need to do like filtering along the way. I don't really even know what to do with the transconductance stuff. As soon as this becomes, oh, there's still stuff missing. Hold on. There is a circuit here that we're missing. I forgot. Yeah, we need to turn it into current. But that's just going to be a couple capacitors and resistors. So we'll pull that out just a little bit like that. And I guess I can put it in right now. Let's just copy these in. So we've got R there. And then we've got one vertical. Not having to worry about values for any of this stuff makes it nice and easy to throw these designs up. Damn it, this is in the way. Son of a bitch. Just go like giant ass part number. Just go over there. Here, you guys can hang out. There you go. And I need a cap. No cap. We'll go horizontal and then down. Nah, we're just going to have to space it out. This is where the design becomes huge. That's not going to fit. Okay, well. I guess our power supply is going to have to go on this one. We'll just put it over there for now. We'll figure it out later. Because, yeah, this is going to get, because of the vertical trace, this is going to get huge. Big McLarge huge. Just about there. And this one, given a little bit of breathing room. Figure out how much. Whoa, okay. There you go. Get that ground. Dang it. Escape, escape, escape. Ground here. Okay, so that does need to move down just a little bit more. Okay, so that's my spacing. Let's get this over here. Yeah, it's like when you have one of these vertical elements, it kind of messes up your whole compact design. Try to make it able to deal with that, but that, down one. Yeah, we were close. Oh, that's really ugly. That's hideous. There you go. Fix that one up. Okay. And then one more ground. Yeah. Oh, missed. All right, traces. Now, this can take an input capacitor, but I don't use one in this design. So, I mean, I could plan for it and just jumper it if I don't need it. Or, well, we'll just make it the way that it is, and we'll see if, you know, what comes out the other end. This is a lot of components now. There'll be a significant amount of real estate dedicated to getting to and from my components. Why does that have dots on it like that? What's going on there? Information detected at a frontier. Oh god, there's two resistors there. That's why. Okay. So this structure right here is what's turning voltage into current. and then it's going through the transconductance amplifier. So that's unfortunately a necessary structure that blows my schematic up. It makes it huge. Let's give these a little bit of breathing room since we got it. Since we have the room, I'm going to give it a little bit of room to breathe. Take that all the way down to the bottom. Alternatively, I guess what I could have done is go horizontal a little bit with it, and then that would have opened it up a bit. All right, there we go. Nope. Okay. So far, so good. Can you not make the schematic larger? I like to keep it on 8.5 by 11 sheets of paper. And so that's what that frame is helping me do. Frame is actually from SparkFun, but having that little engineering frame also keeps you from having to deal with the existential void. Why am I here on this planet? What is life? Does life have meaning? In the nothingness, I find oneness. Anyway, I zoom in on it, and then you have an 8.5 by 11 sheet of paper that you can work off of. That's just kind of how I do, just because I used to author documents that would get printed out on 8.5 by 11 sheets of paper, and we had to have our completely readable and understandable, simple schematic span all those pages, be nice and spaced out, be as minimalized as possible, but also get all of the features of the design across in sort of an easily digestible manner. Because you would have people that would look at these documents and they would sort of poke in on it and go, hey, what's this? What's this doing here? Why'd you do this way? And they're trying to get like a gotcha. So yeah, stereo mixer. We have 4 channels coming in. They are normalized so that if you have a channel that's not plugged in, it's going to both ends of stereo. That's what that sort of cross connection stuff is. Then they go into a unity gain amplifier where they are actually taken down from the plus minus 10 volts to more like plus minus 3-ish, 4 volts, I think, somewhere around there. And that just gives me the ability to both amplify and dampen the signal. Because it's a mixer, I want to be able to boost weak signals, and the rest of it is attenuation. So those are coming in, and those are coming in separate left and right channels. They've got their little amplifier going on there. They then get converted into current with this little setup here, converted into current and filtered, and then they go into the transconductance amplifier. The transconductance amplifier's purpose here is so that I can do complicated control of multiple channels. So I can have a right and a left on one channel get controlled by one knob, and the right and the left on the second channel get controlled by another knob, and they are completely separate signals. They then get mixed into a singular right and left channel. And believe it or not, the audio mixer is as simple as it just puts stuff onto a wire. I always thought that was kind of crazy that a mixer is literally just, you have this wire that you're putting all of your voltages onto. So those 2 channels, those rights and lefts, are mixed together, and they get a volume control. Much to my chagrin, Julian wanted a volume control. I had the 2164 already, so I decided to double up and have 2 transconductance volume. They're all on one volume knob, by the way. So everything is on one volume knob, but I've got 2 completely separate channels. There were 2 amplifiers hanging out, and so the datasheet suggested that you double them up. And then from there, we go into a current to voltage setup. This is a current to voltage op amp setup. So now we've actually got our signal back on the other end here. It has been inverted once. This reverts it back. However, since our tiny little parts are quad operational amplifiers, I've got 2 amps, I got 2 left over. The headphone amplifier that I'm then putting this into wants a positive and negative signal. So it wants a regular signal and an inverted signal. So I can actually just route the extra op amps. I can just put them in there, and now I've got an inverted signal and a normal signal here in voltage space. So I'm going to put those into the headphone amplifier and then output them onto a stereo jack. Are you just adding or subtracting? You can do either, but mostly subtracting. There's a little bit of adding that can go on there. And all that fits in 2 HP, two rack units, which is 10 millimeter by 100 millimeter. Am I going to be able to fit all the components? I have absolutely no idea. Do not know. There's a chance. I might have to do some weird stuff, but I might be able to actually make it work. And then once I get the PCB made, we can test it a little bit. I can put frequencies through it. I can put audio through it. Whew, okay. That does it for me. That's now 5 o'clock. That's 4.5 hours streaming. 4 hours and 12 minutes. Okay, so maybe not 4.5. But yeah, I gotta fit all this stuff. this increasing tower of components has to somehow fit onto this board. It's gonna be a challenge. We've got a little bit to go. Tomorrow we will add the headphone amplifier, and I will get that component. That's going to be a special component. Let me just make sure I haven't already built it. What is it called again? It's the... Get out of here. The component is called... TPA 6120A2. Oh, sweet. I want to see that. Yeah, I'll take a look at that. Where's that? People can't ever get past general. Ah, it's cool as hell. So you're lasering a PCB with a, what is it, a fiber? MOPA fiber laser. Jeez. Get to the good stuff. Get to the good stuff. When does he start the burning? There it goes. Oh! Well, there's a flashing lights warning for you. Is it just going to look like that the whole time? Yeah. Well, look what's coming out the other end. Ha! That's awesome. That's cool. Ta-da! It's a little scorchy, but that's a serviceable PCB if I've ever fucking seen one. That looks awesome. Oh my god, what's happening to that guy's skull? What's this? All right, no distractions. not 2164. It was the TPA 6120. Why am I using the TPA 6120? I could probably output to headphones directly from here. I wanted to have something that did like some extra little things. And so this does little extra things. It's a professional headphone amplifier. So I decided that I wanted to have that in there for its extra special features, like low crosstalk, power supply, good voltage noise, current feedback architecture, THD of something or other dB, signal noise ratios. I don't know, man. I just thought I needed it because I don't really know how to drive headphones. So I decided to buy something that would do it for me. 6120A2. Do I already have that part? Oh, wrong. Chips managed. No. So we'll have to build that tomorrow. We'll build that component. We'll get that together because it's kind of got a special footprint that we'll have to cater to. So I'm going to hit save on this. And I'm going to go over to, I didn't do my admin card, did I? Do I? This next one is going to be the 20th, which is a Friday. Hey, happy Thursday, everybody. 20. Some of y'all are in Friday already. Here's the end card. This is where you can find all kinds of stuff from me. Hold on, I gotta find where's the end? There it is. So if you guys are wondering, like, you know, there's Blue Sky and Discord is especially where I spend most of my time. I am going to go touch grass because apparently Twitch thought I was the grass touching a streamer. So I'll catch you guys tomorrow. We're going to do more of this stuff. It'll be another AutoCAD sponsored stream where, you know, we just try to build this PCB. I'm hoping we can get it into the realm of actually tracing out stuff, actually putting traces down into, you know, all the decisions that are part of that process, because there's a lot going on when you're putting together a PCB like this. We have a huge space restriction, so we got to get the rules in, so it knows the rules, and so do I, and then we'll start putting down the little traces and see how it's going to work. But all right, I will catch you guys later. Have a good one.